Good afternoon, everyone. A very warm welcome to Open Source Conference 2022. Once again, organized by Samsung and IEEE ComSoc Bangalore chapter. With the support of our standards partner TSDSI and our media partners, Open Source India and Electronics for You magazine. It's great to see you back. This is a third edition. Some of you might have joined our past two editions as well. A very warm welcome once again. Year on year, we have been building the theme, which is not only just incremental, but futuristic as well. Today, we're going to be together for like 4 hours with the power pack performance from industry leaders, ranging from tech talks, virtual demos, and a live panel session. So without taking much time, I would like to just highlight our agenda. This is our agenda flow for today. We'll start with the keynote. We have Dr. Aloknath De from IEEE and Corporate VP Mohan Rao Goli from Samsung Research. Henceforth, we'll be flowing through the tech talks, virtual showcase, and at the end, we will be having the live panel discussion with our 6 panelists. I would like to invite Dr. Aloknath De, Chair-elect 2022 IEEE Bangalore, past Chair IEEE ComSoc Bangalore. He's also having a hat of Samsung to address the audience with IEEE keynote.
Thank you, Dwarka. So greetings to all and a hearty welcome to all again on this third edition of Open Source Mini Conference organized by Samsung Bangalore and IEEE ComSoc Bangalore. Today, broad theme is proliferation of open source for emerging technologies. Let me set a bit of context of the event. As a CTO of Samsung in India, I was nurturing this open source, how to grow and open innovations. So since this is an important component, being also chair in IEEE ComSoc Bangalore in 20 and 21, we thought if we can combine these two great platforms, we can nurture this topic well. And that's how it is formed. And ComSoc Bangalore has been exploring different aspects of communications. Dwarka Dayama has been instrumental and he's also today's convener. So thank you, Dwarka, again. In the first edition, I talked about trends in open source and telecom. Also, Samsung's journey in Tizen, for example, this is an operating systems for IoT, OS for everything, and many of our products have been based out of Tizen. Then we went on to Open RAN, IoT, edge computing, and some of the glimpses have been shared in the last events. Those who are here today, they all understand very well the importance of open source and trends. Nonetheless, the world is changing fast. So we will have today also a session which is highlighting state of open source, trends, insights, and lessons. In the first version itself, not just from Samsung and IEEE, Subodh from Cisco and Vinay from Red Hat, they've been speakers. And they're very passionate and they've been joining, speaking in the second editions, and today also they're there. So it shows some confidence and growing the strength of this open source movement. Last edition, we had Silona from IEEE SA Open. She's chair, and Arpit from Linux Foundations, Timo from Red Hat, Thoralf joined from Nokia. We had many hands-on and effort, even though online, virtual, but tried to do some hands-on kind of sessions. Last time I remember we had a great panel discussions that I moderated, but let me recognize again the IUDX, the data exchange, the Airtel, the Neural Network, the Infosys, those who all have participated in this forum. When I approached Open Source India magazine, they heartily joined us last year to promote and publish our panel conversations. They published a great article on our findings and discussions. So this is third edition. Details are in your hands. I'm not going to repeat. Dwarka will take you through. But some changes that we tried to bring last year, we talked about 5G and IoT edge computing. We are keeping 5G, it's important. It's getting deployed in India, lots of buzz. So I think we will have discussions around communications. But we also thought, let's have a panel discussion on the metaverse. There is new buzz that is there. Even though none might be expert, but all of us are doing few things around it. And can open source help there? What's going around it? So through a panel discussions, we will have it today. We are having 2 virtual showcasing. Also, I'd like to thank Open Source India magazine for joining us again to promote. Electronics for India has joined, and it gives us confidence that TSDSI, India's standards defining organization, has also joined us this year. And thanks to Samsung India to partner with IEEE, VP Mohan has joined, and he would speak for continuing this journey, and we will take it in a bigger way. So let me thank you all on behalf of IEEE Bangalore section, our ComSoc Bangalore, on behalf of the Exicom, the current chair, Ganeshan Tyagarajan. I wish you a great learning from this conference, and we hope to make it a one-day physical event next year, maybe in hybrid elements, but definitely we'll make it longer, make it a bit more hands-on, and we hope to learn together with networking and take this open source idea much more forward in India. So thank you again for joining, and over to Dwarka. Thank you.
Thank you, Dr. Alok. That was a great start, just to highlight our past and what we are thinking about the future. So moving on to our next speaker, I would like to welcome Corporate Vice President, Samsung R&D Institute, India, Bangalore, Mohan Rao Goli. Just to take us through a journey of Samsung, how it has been, what are the Samsung's vision in open source, and also to plant the seed for such more future events, as Dr. Alok mentioned. So Mohan, over to you.
Just a moment. I hope my slides are visible.
Yes.
Can't see my video. Okay, 1 second. Yeah. Okay. Okay. So good afternoon, everyone. Thanks to Dr. Alok for that wonderful opening note to start this year's chapter of the Open Source Conference. So like Dr. Alok mentioned, so from past 2-3 years, we are having very good run on the open source conferences in India. So we are really excited today because there's a lot of very excellent series of events and talks, panel discussion is there in this conference. Thanks to Dwarka for the setting up this particular amazing agenda. And it's not easy to bring many people, various quarters of their life, and joining together and then making them into this particular platform and then bringing them to this particular conference. Thank you, Dwarka. And it's very overwhelming to see that people from academics, startups, corporates, standards, many various backgrounds are joining here. And I hope that we can get the diversified thought process during this discussions, and there will be inclusion in this action. So Samsung journey towards the open source, like Dr. Alok briefly explained, but let me little bit moderately explain that when we started, we humbly started during the 2000, about 2 decades ago, right? So with the Linux-based PDAs, and today we have millions of devices ranging from smartphones, home appliances, and network solutions. Most of these particular products are powered by some or other very important open source projects, be it WebKit, which powers our Samsung Internet. IoTVT is the backbone of our IoT protocol devices, smart devices. Tizen is the backend platform for us for all the IoT related devices. Of course, Android-based smartphones, we have created a Galaxy series, and ONAP and ORAN software community, and you see the MPEG, EVC, several of these open source projects are getting participated in our device ecosystems. At Samsung, really, we really believe that open source is synonym of innovation accelerator. It can be built, open source can be built and can be promoted in the enterprises by having very important framework, and at the same time, there should be an anchor point. Framework can be created that which open source projects need to be contributed, it should be used, it should be reviewed, it should be committed, etc., etc. But the framework is anchor point is also very important to set up that by setting up the open source programming office. This OSPO structure, it is evolved with the time, and every organization has their own elements. But in our opinion, in my personal opinion, the key element of the open source program is to give that openness to the community or bringing to the community, and at the same time promoting the collaborative innovations. That should be the remain same. So at Samsung, we really committed about the open source journey and open source communities and collaborative innovations. Like Dr. Alok mentioned, we have started the Samsung Open Source Conference in 2015 in Seoul. After having huge success about our opening conference by having very industry leaders coming up and then sharing their own thought process, we have been conducting this event every year in Seoul R&D campus. The campus has, by the way, has very good research facility and world-class innovations will get invented over there. After tasting a lot of success at the Korea and in Seoul R&D campus, 3 years back, we humbly started by Samsung R&D India Bangalore by having very good collaborative workshop in December 2020. And last year we had a good mini conference and towards the area of 5G actually, 5G and IoT, like Dr. Alok mentioned. This year we are continuing the stream of having this particular conference with a very grand theme of 5G and Metaverse. If you see that latest tech trends, the one word that is very prominently heard is Metaverse. There is something common about this particular Metaverse world that the people are talking about it, and then especially Gen Z is very gaga about the Metaverse world. So when it comes to the technologies perspective, it is about interoperability, co-creations, regulations, adaptability, and many such kind of keywords are coming up. But I believe that By having all these keywords can be satisfied by having open source and standards coming together and defining it. Ladies and gentlemen, today, without having any consumer, there is no product. But at the same time, without having an ecosystem, there is no economy. So open source and standards will play a very important role to build this platform and ecosystem for Metaverse. Metaverse, I think it will demand high technical expertise in multimodality, intelligence, sensor-based technologies, efficient connectivity, and at the same time, graphics knowledge, computing powers. All of them need to evolve to give that very, very important metaverse experience to the consumers. When it comes to the connectivity, the seamless connectivity can be achieved through the 5G. So 5G will give that larger throughput, low latencies, massive type of machine connected devices. So various things that 5G is offering, and then it is visible in some of the countries. Of course, in India, this year we are going to launch the 5G, probably with the auctions coming in. But silently, 5G is also creating very important flexibility to the telecom operators. In terms of the virtual RAN and the ORAN, there is a big business change, and there is a lot of flexibility is getting given to the operators who are investing a lot of money into the 5G's infrastructures. ORAN Alliance and ORAN software community has been playing very important role by providing this industry grade solutions which are interoperable, vendor agnostic, hardware agnostic. So operator has a power to choose which vendor, which hardware, which piece to interact with each other. Whether it is a radio unit coming from the vendor, one different vendor, and then the distributed unit coming from the different vendor, and how to align using these particular pieces in the network element through the ORAN alliances. Samsung is one of the key contributor for ORAN software community, and we will continue to be committed for benefit of the industry and society. Ladies and gentlemen, let's sit back. There are so insightful discussions and panel discussions and presentations are planned during this particular conference. I'm really excited to hear and carry some insights towards from this conference. Thank you so much to the IEEE ComSoc to co-hosting this particular event. And I'm sure all of you will be excited and then carry forward some of the learnings through this conference. Thank you.
Thank you, Mohan. That was a great start together with Dr. Alok. I'm sure people had a great warm-up and are ready to go through the, as you mentioned, insightful and learningful journey with real technical sessions going forward. Thanks. So let's start with the real show, the real technical talks, inviting our tech experts. So herewith, I invite our first tech talk speaker, Mr. Karan MV from GitHub. He is Senior Developer Relationships Manager. He's gonna take us through a broader journey of how the open source industry looks like at the moment. And everyone knows, nothing hidden, GitHub is a mecca of open source. It's something that people admire. So I'm sure Karan is going to bring us a lot of unknowns and knowns in next 20 minutes. So Karan, over to you.
Thanks, Dwarka, for that. Let me quickly share my screen. All right, I hope my screen is visible.
Yes.
Great. So thank you everyone. Thanks Dwarka, thanks Dr. Alok and Mohan for kicking off. So state of open source, some of the trends, insight, and lessons. And what I'm going to be sharing with you is a research that we have done, which combines telemetry from more than 4 million repositories on GitHub and surveys from more than 12,000 developers. And this approach really reveals some different trends and also gives us some predictive results. So we can now see with more precision how to achieve some successful outcomes for developers, teams, organizations, and communities. So stay put with me while I talk to you more about this. Hi everyone, I'm Karan and I'm a senior manager for international developer relations here at GitHub. And I work on supporting developer and open source ecosystem in various different regions around the world and help them be more successful on GitHub. So in case you're not aware of GitHub, let me give you a very, very, very quick overview. GitHub is where the world builds software. So more than 83 million plus developers and 4 million plus organizations are using GitHub today. And the open source ecosystem is seeing more than 2.6 billion contributions per year, thousands of open source communities, and more than 200 million plus private and public repositories on GitHub. So this is where a lot of the activity around development and open source is happening clearly. So just, if you were to look back, this is, all time, if you would just take a step back and look at, probably just the past year itself, you can see, just in 2021, there were more than 16 million plus new users, and 84% of Fortune 100 companies using GitHub, 61 million new repositories, and 170 million pull requests that got merged. So a lot of massive activity around open source and GitHub itself that's happening. And very, very interestingly, and I'm glad that we're Samsung is doing this in India, because if you were to look at what this really looks like globally, geographically, clearly India is one of the places where a lot of this activity is happening, where a lot of open source contributions are happening and a lot of development is happening. And just to give you a very, very quick overview on what this looks like specifically for India, here we see more than 8+ million users on GitHub in India. And just in the last year alone, we saw 200+ million contributions to open source from India just in the last year. And the amazing part, and this is my favorite stat, is that more than 10+ million software packages around the world, software projects around the world depend on packages that were created in India. So a lot of innovation, a lot of development, and a lot of contribution to global software economy is happening right here from India. So that was, a very, very quick overview on GitHub and then, what's going on here in India. So let's jump in to some of the trends and the insights and the lessons for the next few minutes. There are largely three things that I want to cover, and I'm not going to be talking about what all is happening in open source, etc., because there is some real good content out there on the internet, including Open Source India, where you can learn more about the open source industry. I want to double click a little bit more and talk about some of the other trends and the insights and the lessons that will be helpful for developers, teams, organizations, and anyone really when it comes to open source. And those three things are talking about communities, sustainable open source and development communities, about documentation, and about developer experience. And I'm going to be talking only about trends, so these are trends that we have observed, some of the insights and some of the lessons that we are getting out of this. So let's jump into the communities part. So just if we look at the past year itself, GitHub welcomed more than 1.4 million new contributors to open source, and our community continued to build software that powers the world. So it provides a sense of community and gives us a place really to make and create something bigger than ourselves. And open source contributors have been continuously growing. So in fact, in 2021, there were more than 3 million first-time contributors to open source projects. And it's only growing. So people who are just getting started and helping build this ecosystem are also growing. So what that brings us to is a really very key important aspect of how do you help all of these first-time contributors to open source. And the key answer to that is really about mentorship. Mentorship goes a really long way, and it's in fact a community asset. So when new contributors get really friendly and timely reviews, and there's a commitment to mentorship from the teams itself see a positive effect on productivity. And this we've seen has resulted in a 46% improvement in open source and a 16% improvement in productivity in companies. And beyond productivity, though, mentorship can also be a multiplier for healthy and sustainable communities. So explicitly providing mentorship almost triples the chances of an open source team having a healthy culture, as well as contributors feeling they belong in the community and identifying with the work they do. So for teams at work, mentorship almost doubles the likelihood of a strong culture. And that's what, is really about having a good trust and respect when it comes to a culture in open source. And we found a very, very strong positive effect that was, in a way, surprising, higher in teams at work than teams in open source. So, teams with a high trust are more likely to have a very healthy collaborative culture, which was double more likely in companies and triple more likely in open source. So the underlying fact here is that with more and more first-time contributors to open source increasing, mentorship really contributes to a developer's sense of identity and belonging in their community. But a very strong culture can actually reduce the need for mentorship itself. So investing in mentorship for a lot of the first-time contributors is an investment on improving culture, which again has a long-lasting benefits for productivity, satisfaction, retention, and a whole lot of other things. So, it's also about where are really people contributing. All right. So if you look at this graph, I'm not sure if you can make out the actual repositories or what is being shown over there, but you can see that people interested in open source can get involved through hobbies and special interest groups and not just deep technical communities. So if you look at the percentage of contributors who have an account age less than 2 years, you can see things like a lot of fun repositories which are getting people started, getting developers started on the open source journey. And if you were to just break this out, all of these top 20 repositories into categories, you will notice that these are categories which are topics like gaming or manga or science and education, etc. Right? So people are getting started, developers are getting started with the first time contributions in these areas, and then kind of moving on to deep technical community. So these are some interesting trends when it comes to communities and what's happening in open source related to communities. But often the key thing for all of these contributors, anytime I spoke about mentorship, but also a more important second aspect, which I just very briefly mentioned to you about, is also documentation. And I know if there are developers here in this audience, you would surely relate with this, because documentation is a very, very key aspect of getting any developer or even an open source contributor get started. So I would say that no matter the format, documentation is important. And building on top of others' work in a community-like way can be an accelerator. And this is true both in open source as well as in companies. And Documentation also often signals if a repository is reliable to reuse code from, or if it's an active project, to really contribute to. So what signs are developers really looking for when it comes to documentation? So at work, developers consider documentation trustworthy when it is up to date, for example, looking at timestamps and things like that, and has a higher number of upvotes from others. Open source projects use things like READMEs, contribution guidelines, GitHub issues, and other things to really elevate the quality of any project and to share information that makes them more attractive to new contributors. And enterprises, in fact, can adopt the same best practices to achieve similar success. But in both environments, that is, in open source or at work, developers see about a 50% productivity boost when documentation is up to date, when it is detailed, when it is reliable, and comes in different formats, like articles or videos or forums, etc. So think about this part, and then probably something that you can review with your team as well. When was the last time you updated your documentation? Can everyone on your team improve the documentation? So this is something that you can actually check frequently to stay on track and help improve the productivity of developers, both in your companies and also for open source. But that said, I know it's a very, very important thing. Documentation is very critical, but often an under-resourced area of projects, despite being critical to onboarding new contributors, improving the quality of work, and also creating shared understanding. So really sharing and sourcing knowledge through different forms of documentation improves productivity both in open source projects and also at work. So, internal documentation could be something around onboarding, governance, tutorials. That's just the structure and dependencies, best coding practices, and a whole lot of things. So essentially what this also serves as is creating a rule of engagement which removes ambiguity and friction. So when companies work closely with open source communities, making the conventions of a project clearly understood facilitates building on each other's work. Otherwise, there would be a lot of questions in terms of how are you supposed to do this? How are you supposed to do that? And there'll be a lot of conflicts within an open source project by people within a company, within the community, etc. So, which is why I said contribution guidelines, for example, have really gained traction as rules of engagement when creating enterprise level open source software. And here's an interesting analysis that we saw was that repositories that are used for both open source as well as work are more than 4 times more likely to have contribution guidelines than other repositories, which underlines really the fact that making these rules of engagement really remove all of those ambiguity and friction and helps you move faster. And here's a stat that can really show you. So this is, just a very brief percentage on repositories with and without contributor guidelines. So you can see, a lot of open source projects itself, in fact, don't have many contributor guidelines, whereas projects which are used both in open source and at work have a really higher likelihood of having contributor guidelines. So why would a company really want to add contribution guidelines to its repository, right? So when developers know how to contribute to a repository that belongs to a different team or a community, it really removes ambiguity and friction, and they're 17% more productive. So this was, of course, around contributor guidelines and documentation, but one of the things that you would have very easily seen anytime you're using any open source project on GitHub is READMEs, right? So open source repositories often use READMEs to share information and also to signal that a community is active. And our analysis really found that work repositories use READMEs considerably less than open source projects, but this could also be because they share documentation and information in other internal forums or methods, as well as kind of pairing or onboarding buddies for knowledge transfer, etc. But you can see, on the other end, a lot of open source projects use README, almost like 85%. So see if you can try incorporating a README to your repository to keep essential information closer to the code, so it becomes easier to share information and also to signal to the external community that you are active. And one of the other last things that I want to share with you also when it comes to documentation and some of the trends that we have seen when it comes to documentation is that GitHub issues are also documentation. So this is another way to share information about a project on GitHub. And creating issues is the most common first contribution and invites non-code contributors as well. And this provides a great way for people to join GitHub and help manage projects. So think about your own projects and new team members. Can folks really jump into projects by creating issues easily? So evaluate how you are using things like GitHub issues on your open source project or even at work. And if you don't believe me that GitHub issues really help in documentation, here's an interesting stat that I have for you on what do people do on their first hour on GitHub. On their first hour on GitHub, people are actually creating an issue. So if you just look at these bubbles which indicate creating an issue, pushing, or create a pull request, etc., a lot of people on their first hour on GitHub are creating an issue. All right. So if you're really attracting new contributors and looking at how to engage them, issues could be a good way. And there is actually a way on GitHub that can help you with something like this, what is called as good first issues, which really guide new member contributions. So marking GitHub issues as good first issues is a great way to guide new members to their first contribution. And large repositories are generally more likely to use good first issue labels. And it's a very effective practice. So repositories where, almost 21 to 30% of issues are marked as good first issues have almost 13% new contributors. So if you take a look at this stat where you're looking at the percentage of new contributors by whether a repository has any good first issue or not, you can see that it's a lot more higher, on an average 12 to 13% more when you mark issues as good first issues. So we spoke about a lot when it comes to documentation around how contributor guidelines is really affecting people, improve productivity, how having READMEs is helping share information, how issues can help you attract new contributors, etc. But the underlying fact that I want to highlight is that documentation is good for both productivity as well as culture, and it's a win-win. This is the trend that we have seen in the analysis of what I mentioned, 4 million plus repositories, and also survey from 12,000 developers across the world. Now, the last point that I really want to touch upon, having spoken about communities and also documentation, is the last thing around fast is better. And what do you mean by fast is better is a developer experience itself. And this is something which is there on everyone's mind. At work, developers, managers, organizations, and everyone want really tools and processes to be fast, delightful, and really easy. And similarly, in open source, project leaders and maintainers look for ways to make communities welcoming and sustainable. So what are some of the trends there? How can we all make that happen so that the productivity of this whole ecosystem is better? And one of the first clues over here is that developer productivity is really about making work better for developers, all right? So better coding and automation is about more than speed and productivity. It also helps improve collaboration and culture. And really, it's again, when I emphasize, it's about automation, all right? So good automation helps teams communicate better and more clearly. And also the research shows that better information flow is key to a better culture. So really it's about having better tools also helps developers feel empowered to do their work and feel very much fulfilled in the work that they do. And so developer patterns, in fact, on GitHub reflect that automating software delivery is a very key enabler in open source and also helps team go faster at scale. So we see that really large repositories use features like GitHub Actions very, very proportionally higher more than small or medium-sized repositories. So if you look at this, once really large repositories start using features like GitHub Actions, teams merge almost 2 times more pull requests per day than before. So that's almost like a 61% increase, and they merge 31% faster. But if you look at really across all open source repositories, using automation features like GitHub Actions or anything other for that matter, increases the number of merged pull requests by 36%, 1/3 faster, and also shrinks the time to merge by 33%. It's a win-win of 1/3 on either ways by incorporating automation in your delivery workflows. So here is, a tip is see if you can try implementing automation around your pull request to improve your team's productivity. So here is just again another example. If you were to look at the percentage of repositories which have more than 1,000 contributors, you can see, be it in open source, be it at work, or be it even at open source at work, a lot of heavy users using automations like GitHub Actions to achieve their software delivery workflows. And there was, a lot of mention that, Mr. Mohan and Dr. Alok also mentioned around collaboration and coordination. All right. So how does this work when it comes to open source and on GitHub? If you've used GitHub anytime, you know that pull requests really are the way how development teams really coordinate and build software together. And this year, we saw that pull requests are merged the fastest at work, in fact, which is almost double faster than open source. And we also saw that pull requests at work are merged 25% slower than last year. So when we compare the previous 2 years, we can see signs that, the work rhythm is slowly returning back to pre-pandemic levels. And here is what I was talking about. If you were to look at, the median hours to merge pull requests, I think there's a slight lag here in my slide moving across. So just give me a moment. Okay, here is what I was talking about. Is if we were to look at the median hours to merge pull requests, where pull requests had at least one reviewer, there is of course, a better growth when it comes to open source, where the median hours is around 11 hours. But you can see open source at work growing all the way to 10 hours. And with work, it's kind of coming back to some of the pre-pandemic levels as well. So really the last thing that I want to leave you with is 3 key things that can help you, your ability to merge pull requests quickly and move faster is really assigning no more than 3 reviewers to a pull request in an open source repository increases the chances that it will get merged within 24 hours. And this is the analysis that we saw. The second thing is that at work, pull requests with just one reviewer are often merged within an 8-hour workday. And also a lot of the automation and community help us build better together. So this was, some of the really quick trends that I want to share with you, some of the insights when it comes to what's happening when it comes to open source communities, where are the contributors coming from, what does it look like, and also talking about the really importance of documentation, how it helps productivity, how it helps culture, how it helps developers, open source teams, and also speaking about developer experience and how you can kind of repurpose some of your workflows based on what is happening out over there and some of the analysis that I showed you. So that's all that I had from my end. Thank you so much for being patient and listening in on this. And thank you, Dwarka and the entire organizer team for this. I see on my clock 25 minutes 10 seconds. I hope I'm on time. So thank you, everyone.
Yes, Karan. Thank you very much. The stats were really interesting. Never expected that the trend has been shifting so much between post-pandemic and pre-pandemic. I think that proves that GitHub has a real data. Thank you very much. Since we have time limitation, if there is any question, do post in the chat. We'll try to answer in between or maybe answer it offline to you. So I would like to invite our next speaker, Dr. Chandra R. Murthy. He is professor at Department of EC, IISc Bangalore. He is going to demonstrate us and explain us something around open source 5G testbed, which is an upcoming new project at IISc Bangalore. So Dr. Chandra, over to you.
Thank you very much, Dwarka, and I'd also like to thank you and Dr. Alapnath De and the rest of the organizers for giving me this opportunity to speak to you about building an open source 5G testbed. I suppose you can see my screen and you can hear me clearly. If not, let me know, but I will get started now. My name is Chandra. I'm a faculty in the ECE department at IISc. So this open source effort is part of a project that was funded by the Department of Telecommunications, Government of India. It has been running for about 4 years now, and there were 9 principal investigators on this project. The project itself officially ended January 1st, 2022, and now we are on to something called a operation and maintenance part of the project, where we maintain the testbed, encourage usage, and continue to do other minor developments. So right now we have only about 10 engineers working on the project. At the peak, we had almost 40 engineers working on this project. We've also been assisted by several senior engineers. Currently, we have 2, but previously we had another 3 or 4 extra. Okay, so this is one slide overview of the different aspects of 5G that we looked at in this 5G testbed project. There were 4 parts: the sub-6 gigahertz system development, the millimeter wave system development, the vehicle to X platform, and the visible light communication system development. Of these, in this talk, I will focus on the sub-6 gigahertz development platform, because that is the part that is actually open source or based on open source. And in it, we have primarily looked at physical layer enhancements, implementing the split 6 architecture, also called NFAPI, MIMO algorithms, and integration with different radio units. So for the sake of completeness, in the millimeter wave FR2 platform, we've developed antenna arrays, 16 by 4, that is a 64 antenna array with an up-down converter and transceiver. And we've also tested it extensively in an anechoic chamber that's available at the ECE department. In the vehicle to X platform, it's an LTE-based platform because we wanted to use a fully functional platform to do end-to-end latency measurements. We've enhanced the max schedulers in LTE, really reduced the latency of a native implementation of LTE by a factor of between 5 and 10. And also demonstrated remote driving capability on campus. Visible light communications is basically a complementary technology to 5G. It's not part of the mainstream, but we have built a VLC communication system which is able to deliver about 4.8 gigabits per second using OFDM. And it also incorporates beam steering, and we have the technical know-how to create a VLC backbone. The website listed at the bottom has many more details and several short videos of different accomplishments on this project. So as I said, I want to focus on the sub-6 gigahertz system. We are using generic radio platforms based on the Universal Serial Radio port made by Etios Research, which is now part of National Instruments. And these are capable of operating anywhere up to 6 gigahertz, but primarily we focused on the 3.3 to 3.8 gigahertz frequency band. The other features of 5G are all supported by our testbed, including 30 kilohertz of carrier spacing, 100 megahertz bandwidth, 2x2 MIMO, and up to 256 QAM. Split 6 architecture is something that we contributed to this open source effort, and there's also something called a 3/4 sampling mode support, which is necessary if you're using these USRP X310 hardware platforms. So the main idea of the value proposition of this testbed is that it's a fully open source platform. So every part of the 5G new radio stack is available open source, and one can modify it, enhance it, and observe the performance. In particular, we've well tested it with these USRP radios, and we've extensively characterized the physical layer performance. And we've also tested the setup with commercial UEs or phones, in particular the OnePlus 9 Pro 5G and the Oppo A74. This is roughly what the system looks like. So essentially, we have these USRP radios, and these USRP radios are connected to a PC where the G-Node B software stack is running in a monolithic implementation. And then they are connected over the network to, we have tested with 2 different 5G cores. One is the Open Air Interface 5G core, and the other is the Open 5GS core. In fact, Open Air Interface uses, I think it started out using GitHub, but now they have a version of GitHub that is local to their, to Eurocom. It's a university in France, and they call it GitLab, but maybe it is in some form GitHub itself. Yes, so the core is running on a different PC, and these USRPs essentially act as G-Node Bs or base stations, and these can be connected to either user equipment software, which is again running on a PC, connected to another USRP, or it could also connect to a commercial 5G phone. So this is actually a code snippet, basically to show you that there are different types of radio hardware that the code base actually supports. In our IISc lab, we use the X310 and the B210s. And for synchronization, if we have multiple X310s connected, then we use an octa clock to synchronize them together. Although this octa clock is strictly not necessary, it just makes things a bit easier to use this octa clock, which has a GPSDO module. We have done various types of experiments, including hands-on experiments on the RAN side, looking at the impact of different RAN parameter settings, and looked at different types of real versus simulated systems with different types of antennas, and how that affects the connectivity and the data rates that we can get. And there are also simulators. So for example, you could actually run the G-Node B and the UE software on the same machine, and then test the data rate and so on. Also on the core network, we can, since it's all open source, we can understand the configuration of the AMF, UPF, and SMF, etc., the various personalities that are part of the core network. We can investigate the 5G procedures and 5G NR standards. So really, essentially, it allows you to see 5G actually in operation and look at different SIM card functions, and then install and run an end-to-end 5G with a commercially off-the-shelf mobile phone. So this is a short video. I actually have 2 short demo videos of what we have done. I'm going to play them. Let's hope you can actually hear the voice also.
Hi, I am Sudhakar, Testbed Manager at 5G Testbed in the Indian Institute of Science, Bangalore. Today I am demonstrating the physical layer model.
Are you able to hear the voice? Can somebody confirm? Okay, thank you.
The transmission and reception using the OpenAir interface NR code base. Here I am using a PC to configure the GNodeB software, which is based on the OpenAir interface. And this is my GNodeB monitor. To this PC, I'm connecting a camera and taking the USB feed using an FFmpeg software and feeding that signal into the MAC layer of the GNodeB. And that is getting transmitted using the USRP X310. And over there transmission is being received on another USRP, which is connected to a PC, which is configured as a NRUE system. And as I explained, the camera feed, whatever I have been transmitting from the GNodeB, which is being received on this NRUE, and that signal is being displayed here. And this is the way the constellation is. And similarly, I'm taking a video signal on the uplink, which is a pre-recorded test video signal that I am feeding into the physical layer of the user equipment on the PC. That is getting transmitted using the UE related USRP and getting received over there on the GNB USRP, getting processed in this PC and being displayed here. Thank you.
So this setup demonstrates the working 5G network in a lab environment. So basically, 5G network has three components. Any mobile communication network has three components. One is the core network and radio access network and UE. In this setup, core network is running in this system. Radio access network using OpenAir interface 5G is running in this PC, which is using USRP X310 as for the radio interface, and this is the UE 1+9 Pro as UE. So these three components are the part of the 5G network, and you will see connected and working 5G network in this setup. So I'm just going to start base station here in this PC. So when GNodeB started, you can see in the core network log that whether how many GNodeBs are connected, whether it is connected or not in the core network log. So now the GNodeB has started and it is healthy. Now I'll try to latch this UE 1+9 Pro to the base station over the air interface. You can see now that this commercially available mobile phone for 5G, we're able to connect to this network and able to browse YouTube video.
Okay, so just to continue along, we've also contributed to the 5G Hackathon India, and three of our entries, we had 3 entries from ISC in the 5G Hackathon conducted by DOT recently, and all 3 were selected among the top 100. 2 of them were also selected among the top 30. The third one somehow stopped at the second stage itself at the top 100, and they did not submit a next version for the top 30 competition. Okay, so I wanted this talk to be more about the future rather than what we have done in the past. So now I will talk a little bit about our interactions with TSDSI and our work in progress. In fact, I was asked to present a few slides on TSDSI and their interest in open source. So these next 2-3 slides I'm presenting on behalf of TSDSI. The vision of TSDSI is to ensure that digital communication standards, which are becoming increasingly which are increasingly driving domestic economic and policy activities, which enhance India's competitiveness for ICT goods and services in global markets, and Their aim is to do this by creating a leadership position through India's participation and contribution to emerging digital communication standards in global SDOs. In particular, recently, TSDSI's 5G-I and NAVIC are now part of the 3GPP, and the CIPRI front haul transport standard developed by TSDSI has been taken up by TEC for adoption as a national standard. And basically, in numbers, lots of reports and standards have been published, and the membership has expanded by 10x in the past 8 years. And talking about membership, TSDSI attracts members from all sections of the telecom and ICT ecosystem. And any organization can join TSDSI either as a corporate or an associate or as a guest member. And this allows them to work with all the key members of the telecom ecosystem in India and directly contribute at global SDOs such as 3GPP, ITU, and IEEE. And the relationship is between open source and standards is that essentially open source begins where standardization efforts end, and they can actually augment each other. So for instance, standards can be implemented in open source that can lead to large feedback from the community, which can then further influence how the standards evolve. And in particular, TSDSI set up an open source task force last year to study and evaluate open source components required for building an end-to-end 5G system, and to explore how open source projects can accelerate the Indian 5G ecosystem. And this was done with broad industry participation. Several of those companies are shown here. And these findings were published in a fairly comprehensive 100+ page report in August 2021. And the offshoot of this was that the open source components to build an end-to-end 5G network do exist, but it needs to be put together, curated, and well documented so that it can be used by the community. And this can be a game changer for OEMs and service providers, and it can expedite 5G-I, for instance, and reduce the cost of implementation by a large percentage, 50 to 60%. But as you know, most of the statistics are made up, actually 78.6% of the statistics are made up on the spot. So it can potentially reduce the cost of implementation by 50 to 60%. But a comprehensive, well-tested open source platform with technical support is crucial for developing this ecosystem. And so with that in mind, we recently have a fairly large project which is under review with MIT, where we envisage building such an open source platform which can actually reduce startup friction and development costs for OEMs, and product developers can focus on their core competence. They can develop specific components of 5G and focus on selling those components. And we want to go with something like the Red Hat model, so that there will be a basic software that's available for free. And then if you want support and services on top of that, that gets charged. Okay. So overall, the idea is to have 3 pillars on which this will be built. One is technical leadership from academia with faculty and project staff in academia who have experience with several successful projects, and a dedicated core development team consisting of engineers with prior industry experience, along with strong industry participation through volunteerism to take on specific sub-projects or projects of interest, and overall have a strong and transparent governance model based on technical meritocracy. For instance, IUDX was mentioned by Dr. Aloknath Dey earlier, and he is one of the key, the founder of IUDX is Dr. Inder Gopal, or one of the founders, and he is one of the key members of this project as well. So in simple terms, basically just 2 deliverables on this that we are aiming at. The first is the DU, CU, and 5G core parts of the 5G network. And the second part is going to be on the RIC, the RAN intelligent controller, and the service management orchestration in a cloud-based deployment. And this part is going to mainly focus on Open RAN compliance. So overall, our goal is to have an open source radio access network with an integrated RAN intelligent controller, which will be 100% ORAN compliant, 100% tested with COTS radio units and user equipments, that is commercial phones. And we want it to be a 100% commercial grade RAN with a cloud-based control platform. And we intend to have APIs and enablers for the different the three different important aspects of 5G, including EMBB, URLLC, and massive machine type communications, address different verticals and provide APIs and enablers for them, and have a strong association with partners to develop APIs and applications in verticals of their interest. So this is roughly a timeline of how we envisage this project to proceed. In phase 1, which will be of about 9 months duration, we will target a basic RAN with DU-RU split with static configuration management, but tested with commercial radio units. And in phase 2, we will focus on enhancing the platform to meet the URLLC specs and also create the framework for near RT RIC and non-RT RIC and XApps and RApps. And phase 3 will mainly be testing and cleanup and testing with commercial platforms and so on, and also support APIs or provide APIs for AI/ML algorithm support in the RIC and RAN. So overall, this is kind of the one slide summary of what I just said. We are aiming to start a nice large project on India open source 5G network, which will create an open source 5G platform and anchored in ISC, IIT Delhi, and CDAC Trivandrum as of now. And we will have well qualified software teams that will document the software and provide strong technical support. And from day one, we want strong collaboration with industry players. Therefore, this is really an invitation to participate in this effort. Thank you. And one last thing I want to mention is that the 5G testbed at ISC is actually open for people to use. In order to book to use the testbed, you have to go to this website, 5gtestbed.in, and you will see the various services that are offered in our current 5G testbed. It's possible to register a company and then book testbed usage. Thank you very much. Happy to take questions. Hopefully, I'm not over time.
Thank you, Dr. Chandra. That was a quite interesting presentation, and I think this community today is privileged to see your new project. We are really happy that we are part of a journey now, and hopefully we should be able to experiment it whenever we visit IISc in person.
Yeah, most welcome. All of you are most welcome. Just drop me an email and most welcome to come visit us. Nothing like seeing the testbed, physically and experiencing what it has to offer. Yes.
Right. Thank you very much, Dr. Chandra. We'll take the questions later offline if required. In the interest of time, we'll keep moving. Thank you very much. With this, we would like to move to the next segment of our event. So far, we were in the education mode with Karan bringing in the broader open source insight and Dr. Chandra bringing in the testbed from Academics Premium Institute, IISc Bangalore. So our next segment of the event is a startup track. And I would like to invite our first speaker, Mr. Rishikesh Dewan, founder and CEO of Zero Labs. They're doing quite interesting work, and he's going to take us through some very unique journey on what they're demonstrating or what they're trying to bring in the market, but in the metaverse angle, moreover. So Rishikesh, over to you.
Yeah, thank you, Dwarka, and for the invitation. Let me try and see how do I share my screen. Yes. Okay, is my screen visible?
Yes, Rishikesh.
Okay, thank you. Okay, so thank you for the invitation. My topic of the talk would be mostly on the privacy issues related to Metaverse and how probably we can solve problems that arises because of this. Now, I choose the topic of the title of the talk as Cathedral and the Bazaar. It is actually, I borrowed it from this famous book by Eric Raymond. And anybody who really works on open source and who has really contributed to open source must have heard about Eric Raymond. And this book really talks about why the open source model is very successful and why we should adopt open source model while designing software. I deliberately choose the title of this book like this, knowing fully well that it is a borrowed title, because of the fact that when it comes to Metaverse now, there are some real concerns and real concerns with respect to security and the real concerns with respect to privacy. And there is no better way to solve the security and privacy of Metaverse or any other software than to using open source tools and to develop in a completely open source mode. So instead of the cathedral mode of developing software, it's better to move to open source one, and how probably we can do that. So I again apologize if I have not made a PowerPoint kind of slides. It's hand-drawn in the iPad. So if it is not intelligible, please let me know. I will read it out. Yeah, so the whole idea here is that we talk about Metaverse, and then in Metaverse, we talk about the AR, the VR, and the mixed reality. And in all of these three different things, there are a lot of data that will get generated, a lot of data that will move from one point to the other, and a lot of data that will get stored and processed. So the question really over here is that what is that data and how significant is that data with respect to PII? And how do we really secure and make that data private? Now, when it comes to data today, the experience so far has been very catastrophic in the sense that we all know that there are so many different kinds of social networks, so many different kinds of communication systems available today, but none of them really provides the privacy that a user desires to have. For example, we have seen the Cambridge Analytica scandal, and like this, there are many more where the user's data is used for profiteering, which means that the different types of blogging or microblogging site, uh, they provide a kind of free service, or they provide a kind of premium service, but the ultimate content creator, the content is created by end users, and the content freely flows to the respective company's servers, where the content is misused and shared across multiple different data brokers or multiple different companies across the globe. So today, for example, if you search for something in Google, and after a couple of seconds, if you logged in Instagram or if you log in Facebook, or you go to different sites, you will see that those things starts appearing in those different websites. For example, in Facebook, in Insta, in different kind of websites. So the question, therefore, is how the data is being is channelized or is spread across to multiple different systems like this. So it is of course done via the browser itself, and the browser allows a number of things to be implanted into the system, which constantly monitors what we are typing, what we are transmitting. And of course, the different service providers who in their terms and conditions and privacy policies have clearly stated that they will take this data and they will profile the data, they will do data mining on top of the data, and they might share the data with multiple third parties, and those third parties are not clearly known or not clearly disclosed who are they. So even before we are there in Metaverse, today the state of the privacy of individuals or state of the privacy of the organizations to a large extent is something which is not there. So we have seen a number of things. For example, when you send an email today or when you upload a set of photos to your social media network, although the organizations claim that they encrypt and then they keep the data in their media or the storage media in an encrypted form, but really when it comes to processing, the organizations have complete access to the data. We also know by now that there are a lot of data breaches that have happened. And in fact, the data breach happens each day, or rather each hour as we speak. So by the time we started this event and by the time we close this event at 6 p.m., 6:30 p.m., there are already several records that are breached. There are several organizations that are already will be breached. Some of them we know because they are famous, because they are organizations of repute, and some of them we will not know because they are not worthy to be known. But at the end of the day, data breach is happening and will continue to happen. So the question really is over here that although we are really excited about the technology, we are really excited about the 5G networks, we are really excited about the different kind of advancements in the IoT devices, we are excited about the different kind of devices that are can take photos, videos, can transmit. But the real question that comes over here is that what about the privacy? What about the privacy of the data that will get generated? Because when it comes to metaverse, you are not only talking of static data, you are not talking of somebody taking a video and then uploading it, or somebody taking a set of photos in the beach and then uploading it. You are talking about a 3D environment. You are talking about something more than that. And as we read today, that is going on in this area, and we see that it's not just about the photos and the videos anymore, it's also about reading your brain signals as well. So if all of this data gets generated, then all of this data is highly sensitive and they are necessary. Of course, the PII, and that has a huge impact on individual's identity and an individual's future as well. So, so with before metaverse, I mean, I'm assuming that metaverse is still not there and relevant, and I think it is true. Even before metaverse, which is pre-metaverse, it is very disturbing to know that for each one of us, for example, each one of us that are there in this call, there are already close to 1,500 different types of distinct pieces of information that is already out there in the internet. And this distinct piece of information could be your email ID, could be your date of birth, your credit card numbers, your financial transactions that happened, your recent health records, your spouse's name, and a lot of other things. So a lot of research has been conducted in the last 3 to 4 years on this, on the type of data that is available out there. And it is being calculated for each individual that is there on the internet on a prolonged basis, using different kinds of services in the internet, using search, using different kinds of social media kind of applications. It is about close to 1,500 distinct pieces of information that is already available with multiple different companies and multiple different data brokers across the globe. So all this information about us gets shared without even we knowing that it is being shared, and it is being there with multiple different organizations. Now with metaverse, and I know, and we all know that a lot of companies who are into this pre-metaverse, social network, and all these different types of different types of applications in the internet, most importantly B2C kind of applications, they are already in big time into the metaverse. So they are now propagating metaverse in such a way that it will help create a new kind of social and economic environment around it. But the question really is, what will really happen to the data? So it is, if it is now 1,500 different distinct pieces of information collected over a period of time, it could be 15,000 different pieces of information that could be collected each minute from us. So the idea here is that although we as a tech guys, we are very excited about the technology, we are very excited about 5G networks, we are very excited about the hardware, we are very excited about the software, but there are also a lot of people who are really excited to make a lot of money out of it. So the question is now, as a tech guys, how do we really solve this problem? How do we really solve the problem of privacy, enough confidentiality, enough security, right at the butt, instead of trying to solve the problem 5 to 10 years from now when the state of the privacy is already not there? So this is a interesting line. It's by none other than Tim Berners-Lee. And when he was asked a couple of years back about the state of the internet today, the statement that he said is that I was devastated to see the kind of infusion that happens today when it comes to profiteering of user data across multiple different organizations. Now, when it comes to metaverse, we have to sincerely realize this part, that we have already done a mistake by allowing certain organizations to own the data. So for example, today, if you see, this is kind of a centralized model, the blue box in the middle, and around it a number of different individuals, organizations, companies, or in B2C individuals that are creating content and pushing this to the centralized units. I call it as a centralized unit because it's a single organization, and a single organization might have a distributed system inside it or underneath it. But as a whole, when we communicate and we publish content which is purely personal in nature, it really goes to that organization or to the set of these organizations. So one of the essential things that we have to remember while we do metaverse, or while we set out the standards, and while we set out the different specifications for designing and maintaining the metaverse data or processing the metaverse data, is very important to realize that we go for a pure distributed and maybe even peer-to-peer architectures, where the data belonging to individuals participating in the metaverse world does not necessarily belong to one single organization. Because if it necessarily belongs to one single organization, then the problem starts from there. So this is one of the fundamental shifts that we have to think when we try to design standards and specifications, while we try to imagine how the metaverse world would look like. Currently, this is not there. The standards and the specifications have not spoken anything about it in a very bold way, although there are concerns. There are a number of articles that have been published across the world, even academic journals as well, that talks about it, but nothing fruitful really has come from different organizations concerning the privacy and the confidentiality of users' data. So there is another concern that is important here, is that the privacy or cannot be integrated into the system as a retrofitting model. And this has been tried, and a lot of people have tried doing that in the last couple of years, but it does not work. It mostly fails. So unless we take privacy as one of the first design principles of designing metaverse, it may not work in the long run if we try to create a bunch of algorithms or a bunch of protocols and we try and put it there into the system. Because the number of code or the number of lines of code that may have been written to provide all these different kinds of services across metaverse must be more advanced and must be in a state where it will be very difficult to retrofit privacy into the core lines of code. So therefore, we strongly feel that privacy should be the first design principle when we talk about metaverse and when we talk about designing the software specifications and the input and the output when it comes to metaverse. Now, of course, when we talk about privacy or when we talk about security, it cannot alone be some kind of legislation. For example, GDPR, California Privacy Bill, or in fact the India Privacy Bill, they are good and they are required, but they are not the only answer. They cannot be the answer to solve privacy and confidentiality at the first place. And the reason being is that a legislation works well in the court to argue, but a legislation has no meaning when it comes to data breaches. So data breaches continue to happen irrespective of there is a legislation or there is no legislation. And data breach has a huge impact on the lives of people. So even if there is a legislation that says that the data should reside in the country, the data should not get leaked. If it is leaked, it has to be informed in the next 36 hours or 72 hours or even 4 hours. Otherwise, there is a huge penalty. This will not solve the problem of privacy and security, because when the hacker comes in, he does not look for this breach and for these legislations. They come in, they hack, and they put the data out in the open. And once the data is out in the open, it is the individual that will be at the loss. It will be the organizations that will be at loss. It is not the organization that is the custodian of the data, because the organization can fight a huge legal battle in the court of law, in the court of in wherever these things are applicable. But that's orthogonal to what when the data breach happens. That is orthogonal to what the impact on of the data breach. And therefore, when we have to consider, when we need to think about putting privacy as one of the first design principles, we have no other option but to rely on mathematics, to rely on cryptography. Fortunately, today, as we speak, there are a set of things that have come out, and they are coming out very elegantly since the last 3 to 4 years, and they are in the space of encrypted computing space, where you can process data and you do not really reveal what is the nature of the data or what is the information content in the data. So these techniques exist today in the form of fully homomorphic encryption, in the form of multi-party computation, in the form of differential privacy. There are other known techniques as well apart from these three, but we felt that these are the three predominant techniques that can readily be used to solve some of these problems. We as an organization, Zero Labs, we focus on fully homomorphic encryption. We have a patent and a number of patents that are pending on fully homomorphic encryption. We have tried to solve some of these problems when it comes to processing of large amount of data in a completely encrypted form. We have been successful, and today a lot of our libraries, a lot of our core SDKs have been used in multiple different organizations across the globe in creating an environment where the data is processed, the data is used to infer a lot of interesting results, but all at the same and at the same time, the data is never exposed. No information content is leaked, and even if the data is leaked or the data is stolen, there is no information that can be derived from it because the data always remains in an encrypted form. So the whole idea, therefore, when it comes to metaverse and when it comes to privacy, therefore, is that it needs to be discussed, it needs to be talked, and it needs to come early on. This is the right time, and I take this opportunity to speak because there are a lot of you who are present now in this talk, and you are trying to design the metaverse from scratch or metaverse from different open source tools, and you are trying to promote metaverse using your devices or using your network. Now, unless we design or bring privacy to its core, it will be really, really difficult to control what it may turn out to be. So we call these today as a Frankenstein's world, and we don't know if these things continues like this without privacy and security and confidentiality in mind. It could be a Frankenstein to the power n. in the next 5 to 10 years from now. So this is what I wanted to tell, and what I wanted to express, that is that this is the right time, and we should be talking, and we should be discussing more on how we can bring security and privacy to the fore, even before we lose this opportunity. And after a couple of years, then some of us have to say what Tim Berners-Lee had said a couple of years back regarding the current state of the internet. So this is what I wanted to say to the forum today. So Dwarka, over to you.
Thank you, Rishi. First of all, your topic was quite interesting, and the way you presented is very novel. That proves that you are a startup founder.
Yeah, I am.
Very innovative way of presentation. Especially, I've seen first time someone showing the hand-drawn presentation and showing the creativity around it. Your mind map was very clearly presented in your drawings, and quite interestingly said. I mean, the privacy and data around. I mean, we all unknowingly share a lot of data with multiple places.
Yeah.
But I hope people slowly get educated, and they will be protected by the companies like you.
Thank you.
Thank you, Rishi. So with this, we would like to move to our next speaker again in the startup segment, Mr. Abhijit Chaudhary. He is also a founder and CEO of Neural Network. Abhijit has been with us in last edition as well as a panelist, and this time he has promoted himself as a Tech Talk speaker. So he's going to present something around his company's product in AR VR space. So Abhijit, over to you.
Hello, thank you, Dwarka. I mean, let me share my screen.
Yes.
Hopefully it has come up.
Yes.
Okay. Hello, everybody. I am Abhijit Chaudhary. I'm the co-founder of Neural Networks, and we are working on a private 5G and edge cloud platform to enable Industry 4.0. And today, the topic that we are going to talk about is disrupting the industrial metaverse using open private 5G and edge platform. When you look into a industry setup, predominantly something like a oil and gas, mining, power grid, what we think about, or even manufacturing, is that it's a huge area to be covered. Like it can go from like 10 to 15 square kilometer or more. Now, to really digitize or digitally transform the industry, you need to ensure that all the devices, all the IoT devices, all the robots, or all the drones across the entire area needs to be connected. And you need to run real-time applications to enable the stringent need for industrial applications. So definitely there is a huge, there is a need for a reliable last mile connectivity which supports high bandwidth, also low latency, to enable these real-time applications. So to get into a little more details about that, we have put some of the applications and what are the kind of requirements for that. Like when you talk about AR, VR, of course, which is one of the very important things for metaverse, right? You see that for that you need pretty high bandwidth. Like sometimes you talk about like around 10 gig throughput. I mean, even if not 10 gig, you need at least 2 Gbps of throughput to run that. Along with that, you need low latency. The minimum stringent can be around 1 millisecond, but at least you need a 10 millisecond kind of latency to do that. Similarly, if you want to run like a autonomous guided vehicle, accidents, you have to ensure that you don't have any accidents. You should be able to see the other vehicles around. So you need to really react. The vehicles have to react very quickly. And for that, you would have probably cameras connected across the device or the vehicle, plus a lot of sensors, etc. and you need to process them. Some of the processing you can do, of course, within the car, but some of the processing also you have to do from outside. So overall, you need a kind of low latency, again, high throughput connectivity, ideally to ensure such autonomous guided vehicles to really be smoothly running around, maybe within a factory floor or within a private campus, etc. When you come to industrial automation, I would give an example. We are talking to an oil and gas plant um, in Middle East Asia. They told that they have around 1 million IoT devices to be monitored. So you can see the sheer scale of IoT devices which needs to be managed using the radio, and it is spread over like 10 square kilometer. And because of IoT devices, the replacement, the battery should last for a long time, etc. So those IoT devices cannot be power hungry. It should last for a long time. You should be able to, the network that you have should be able to cater to around 1 million kind of devices over the within a private enterprise. And you also should be able to ensure that you are able to react real time to any emergency situation which comes up. So that is something what we call the massive machine time communication. So all these three components, the bandwidth, the high bandwidth, low latency, and scalable machine communication is very key for Industry 4.0. And to enable that, the kind of application or the kind of solution required is what I would cover here. Like in this case, I'm showing a port and the kind of requirement for this to cover this 10 square kilometer with a mobility to cover the entire area. Existing solutions like, first of all, let's talk about Ethernet and cloud. It won't work because things are mobile. Now, when you bring Wi-Fi into the picture, Wi-Fi, okay, if it is indoor, it's good. Like you can do some throughput, but even if you see, even indoor, when you have to send like CCTV feeds over Wi-Fi, it's not recommended because of the high bandwidth. Wi-Fi is good for our information technology or like Zoom call, etc., where a decent amount of bandwidth over an indoor area can be covered. But when you have to put like a Wi-Fi network over a 10 square kilometer, you would massively need to put Wi-Fi access point every 10 to 200 meters, and that is just not scalable. It will be so costly and like it doesn't work actually. So that way, so Wi-Fi Ethernet is really not a solution for such big area to be covered. And the other option is to use a cellular network. Cellular network, of course, what we think is the right option in this case. And to start with, at this point, we have 4G networks, which are already available. But predominantly, even if you see in India, predominantly 4G networks are of public network. They are not really private network within an enterprise, because enterprise private networks are generally Wi-Fi networks currently. The operator does not come and create a private 4G network for you inside, right? It is there in countries, even in India, there are a couple of setups where it is there, but it is not prevalent at this point. And 4G also cannot scale to the bandwidth and low latency required. And lastly, the cloud. If you see this diagram on the left, it's about with cloud. The cloud is not within the enterprise. It is somewhere else, and there is no guarantee of where the data center is at that point. Even if you know where the data center is, because it is privately hosted, but still you don't know how much latency it will take because it is going through the WAN network and not goes to the public WAN network. So you cannot guarantee the kind of latency which would be required for low latency of 10 milliseconds, etc. Right? That's where I think the network architecture has to change drastically. And I mean, it's a industry which is coming up, and it's the private 5G, where you create an alternate to Wi-Fi network within the enterprises, which is secured and private. So you don't really have to really always work with the operator. You can build your own 5G network within the enterprise, which is cellular, to ensure the low latency and high throughput guaranteed. But at the same time, privacy is also guaranteed, because it is within the net, within your enterprise. You're not taking data outside the enterprise. It is secured. It's in fact, it's much secured than Wi-Fi because SIM is involved here. And along with that, you also need to have a miniature version of the cloud, which we call the edge cloud, to be running within the enterprise. Because if you want to guarantee the low latency required to do your AR, VR, or the video analytics, or let's say the robotics operation or the autonomous guided vehicle, you have to run the cloud or the applications actually within the enterprise. So it has to be within the edge campus, within the edge, and that's what we call the edge, enterprise edge. And then you can also have it connected to the cloud, which the cloud is basically not for the real-time applications, but to send bookkeeping information from the edge. So you would really do all the processing, all the compute, all the connectivity within the enterprise, within the site. Like if you talk about like an industry and something like Tata, who may have 4 sites across India, maybe more manufacturing plants. In each of these 10 manufacturing sites, you can set up a private 5G network, which is independent of the other. But you can also share data between them through the cloud. But that is generally for the bookkeeping and the management data. But for all the data plane or all the inline real-time processing, you would be using the edge cloud and the private 5G network to ensure the connectivity. So I think that is where the industry is shaping, especially to enable Industry 4.0 based operational applications. Whereas the IT applications like our Zoom call or our normal office work using the SAP application, CRM application, for that Wi-Fi is good enough. But it is mainly important for the operational application. And this is almost a $517 billion market of 5G and edge, which is to be disrupted. Now, some of the use cases I'll be covering for that. To start with, let's take a warehouse, which can be an Amazon warehouse, or let's take a Flipkart or a Swiggy warehouse. I mean, such massive warehouses, you want to digitize them, what we call logistics 4.0. So for that, you definitely need real-time tracking of the devices across the warehouse. Then for some of the tracking, you may use drones. You may also use, to move the devices, you can use robotic automation. Now for training the people in the warehouses, you can use the AR, VR based training applications to give them a real-time feel within the, like while they are using, they can get trained on real time, like based on what they are working on within the warehouse, they can get trained. Now, or for example, during remote operation, if you are trying to remotely operate, you are in one corner or maybe outside the warehouse, but within the office, but you want to remotely operate and some of the stuff within the warehouse. For that, you are trying to use this, you are using a 3D kind of imaging and trying to operate that. So that's the kind of remote operation, etc. So these are some of the use cases which are important for the modern logistics within a warehouse. And this definitely needs the connectivity, of course, is important, as well as the edge cloud to ensure the real-time kind of operations there. Next, when you go to mining, predominantly we have studied the Indian mines as well as the mines which are outside India, maybe in Australia. So predominantly there are 2 kinds of mine. One is the open pit mining, which is like a open, like where like it is not closed. You don't have to go inside the tunnel. Basically, you just mine on the periphery and like do the extraction. And then you have the closed pit mining, which is like you go underground, you have tunnels every, like you have elevators in our office. Similarly, you have elevated tunnels. You have elevators within the underground to reach each of the tunnels. There can be around 10 to 20 to more tunnels as you go down. And each of these tunnels are 1 kilometer or 2 kilometers long. Some of them are connected through the railway tracks to basically take the bring the like the mining ore or etc. to collect that. So in outside India, especially in Australia and in other places, we have seen that a lot of automation has kicked in, and a lot of things are automated at this point. And for automated, of course, you need to have connectivity there. In India, still a lot of things are manual. In fact, I remember in one of the mining, they had to go inside the closed pit mining, put a USB stick, take the data out of the sensors on that area, and then take it out and then connect to their that USB to the office in their office to the server, and then see the IoT data. So that is the kind of way that that is there at this in real scenario at this point of some of the mining. So there is a huge opportunity to kind of digitize that, and you can see that to digitize that, one thing of course we need is the automated like vehicles, unmanned automated vehicles, because a lot of times you have to carry the extracted ores from one place to another, and in fact there are some disasters happen at that point. So having it unmanned is very important, and making it autonomous is important. Similarly, autonomous drilling and robotics, right, which are industrial operations. So if you can do it unmanned using AR, VR, and remotely do that, that would be awesome. I mean, that would actually enable digitization of of the iron like this mining. It will increase the productivity, which is very crucial, I think, and it will also be life-saving. Training, of course, I mean, AR, VR, when I talk about metaverse, there are two parts to that. I think training and operation is one part, and the training is one part, sorry, and the other part is the operation. So most of them can be driven using like the AR, VR, and similar technologies, which are part of the metaverse. Then you need drone inspection and maintenance. Suppose you do a blasting in the mining, right? You cannot go inside that site at that moment. You cannot send people inside. I mean, so you can take a drone and take a survey of that area with the sensors and I mean the 4D cameras, 4K cameras, etc. to see that before you can go inside. So those things are very crucial, and when you are spread over 10 square kilometer or maybe more, you need a connectivity of the entire area to do that, and also do real-time processing, which is very key. So these things again can be enabled by private 5G and edge. Similarly, oil and gas divide into three predominant parts. Oil and gas, when there are three parts actually. One is the upstream. Upstream is where you do the exploration, like where we can get extract oil. So a lot of, when you go to Mumbai, you'll see that a lot of like near the like the sea, from the flight you can see that there are a lot of like exploration sites within the sea. Similarly, there are a lot of things coming near Lakshadweep and Andaman also now. There are exploration, these are called offshore, that is outside land. Similarly, there is onshore, like which is there in Assam and places in Northeast as well as Orissa, etc., which is inside the land. They call it onshore upstream exploration of oil and gas. So that is that exploration needs a lot of seismic data collection, and to collect that and monitor whether you are doing at the right place, you need to do a lot of analytics, a collection of lot of data, get analytics, get a kind of real-time feedback, and based on that you can do the more seismic data on the right place, because for that definitely private 5G and edge can play an important role. Next, you have the midstream, which is basically the distribution of the crude oil or the crude oil and gas to the refinery. So that can be through pipelines and maybe ships, etc. I wouldn't say this is the best case for private 5G. I mean, but definitely downstream is another important part where you do the refinery. I mean, basically refining the crude oil to petroleum, etc. Right? So there you have to, and maybe with a drone, with a CCTV camera and a sensor, you have to go to the refinery, ensure that there is no leakage. You detect any leakages, etc. You do the surveillance of the area, and you can remotely do that using AR, VR. So that's another use case for, I mean, metaverse or the AR VR coming into play on like the industry 4.0, especially in oil and gas field. So there is a huge scope of digitization to increase productivity, to save lives, and also we know, right, this oil and gas, etc., actually enables our energy. I mean, our power grid, etc. So it's very important that we increase the uptime and productivity for that, and definitely digitization can play an important role on that. Lastly, I mean, manufacturing. I mean, this is the most common one that we talk about. This is a real use case from Fujitsu that I have taken in. So where in one of their, I think, Oyama plant, so they are using private 5G and edge compute, and they are using it for multiple things. One is the autonomous guided vehicles. So they have put 4K cameras to ensure that the autonomous guided vehicles are moving properly. So they are collecting data from the 4K cameras as well as the sensors on the autonomous guided vehicle through the 5G network to the edge to do the compute and real-time movement. Similarly, in the manufacturing assembly line, they put 4K cameras to ensure that the work being done is done in the right way. They are using AI analytics to do that. So that means you need to do real-time processing and ensure that if somebody is not doing it correctly, you give the right feedback at that point. They do training on the go using AR, VR, and Metaverse for the workers to support the work that they have to do now. So they do the train on real time, and then they can start the work. So all those things are done using the AR, VR setup that they have using 4K cameras, etc. And of course, the IoT and the sensors across. So these are 3 use cases that they have mentioned they're using it. So definitely, again, I mean, this is a direct where they're already using the private 5G as well as the edge compute out here. Now these are the use cases of, like I initially covered, why we need a different kind of network architecture, which is private 5G and edge cloud. Next, I covered some of the use cases of real use cases where you can use metaverse and other underlying technologies like AI, ML, robotics, drones in industry for digitization or acceleration of industry 4.0. Now let's come to the implementation and how we in neural networks see it, and overall that's our perspective too. Like and I'll start with something I think Professor Chandra was talking about TSDSI, and he was also talking about some of the initiatives in TSDSI. So we were also part of that initiative, and I would take some of the slides or some of the pointers we learned there as in this discussion too, and some of them were collected by Professor Inder Gopal. I would like to acknowledge him for some of the data collected that are present, especially in this slide too. So if you see the data center world, right, the data center, the hyperscalers, we talk about the Google, the Facebooks, and the AWS, right? Their data center has moved actually to actually enable openness and disaggregation, especially on the networking and of course in the compute, etc. too. So when you talk about 2012, most of the data centers, I mean that networking within a data center, which needs switches, like routers and other like network appliance, were all proprietary. So they were all proprietary. That means vendor OEMs were owning them. And in data center, you need lots of such devices. So more proprietary devices, and the data center companies were finding it difficult to manage that. It was causing a lot of vendor lock-in, and for them, really, they wanted a mix and match, and they want to maybe have a single OS on that they want to run on different kind of hardware. So those kind of things were not possible. But the data center companies, some of the hyperscalers like Facebook, Google, even AWS, they found that as an opportunity, and they started using some white box hardware. So white box hardware are commercial off-the-shelf hardware, like you have the Dell server, right, or a HP server or a Supermicro server. They are commercial off-the-shelf. Myself as a retail customer, I can buy a Dell server, right? Similarly, these white box servers are open servers based on open hardware design, which you can procure. Like There are some companies which are mentioned on the right that I'll cover. So you can buy those hardwares from there, and on that you can put any software. Like those hardware, commercial off-the-shelf white box are made from various companies. For example, which is mentioned, like if you see my mouse click on the hardware section, right? We have some of the companies mentioned here. This makes hardware like white box hardware. So you can take a white box hardware, and then you can put any open software on that. Now the open software can be from one vendor, like it can be from a vendor who is providing you the routing software, for example. But then what is the benefit you get is that you're not using the hardware and software from the same company. So you have the benefit to choose hardware from various companies who make this off-the-shelf white boxes. This is what we call disaggregation. Like, and then on top of that, you can choose whose software you want to put. Like Light Counting did a survey into 2029 on who are the white box companies on software and hardware, and this is some of the software vendors that they came out, and some of the hardware vendors they came out with. So you can basically take the software from any of these vendors and put on any of this hardware to create your own like a router stack per se, right? So, and or for example, later on, let's say you are using some hardware, but you don't like the existing software, you can change the software, take from one vendor and go to another vendor, and you can still reuse the same hardware. So these are some of the benefits which started coming with this open or the disaggregation and openness. In fact, some of the software that you can put on this disaggregated white box can be also open source, which I'll cover now in the future slides. So the movement from proprietary solution to open and disaggregated software and hardware in the data center started in 2012. In 2012, if you see, I mean, the data center, the white box was around minuscule, maybe 2%. But by 2019, you see that this white box almost dominated the market by around 59%. That was an eye-opener, I think, and that was predominantly driven by the hyperscalers, and I would like thanking to them. So this has been also eye-opener for the telecom industry and a lot of enterprises too. And the disaggregation and openness, which has become a de facto standard in the data center market, is now also moving into the telecom and actually some of the enterprises too. So yeah, so this is how I think this was a time when, in fact, our company we were starting to envisage what Needle as a company we want to do. I mean, around 2019 and we started Needle with the same concept of openness and disaggregation. And over the line in like 2021 and in May 22, you can see that Needle Network Operating System has been mentioned by global ICT research firm, like in this case, like Light Counting in April of 21, and then GigaOM last month itself as one of the global network operating system vendors across the world. In fact, if you see GigaOM, which was in 2022, where we are also mentioned, but interesting thing is that even big companies like, I mean, the bigger companies like Cisco are also moving to the disaggregation, because that is where the market is going. Disaggregation is no more an option, it's a mandatory need of the market. And you would also see that there are, in the software vendor, there are open source players. So that is the interesting thing. Like, you are not only having the proprietary or vendors, you are also having the open source vendors mentioned in the network operating system. And these are possible because you have a disaggregated white box on top of which it can be run. Now coming to the telecom, what we see is that all the operators in the telecom saw the revolution happening in data centers, and they kind of knew that this is something which would be also should be driving in the hardware and the software of the telecom too. And of course 3G, and it has predominantly been driven by 5G, I would say, because 5G, if you see the standards and how it has been coming up, And also with thanks to 3GPP and also some of the initiatives through ORAN. And then Open Compute, of course, is the hardware part. Then TIP. We talked about TSDSI as a standard from India, so they have also been playing a role out here. Then the Linux Foundation, all of them have been playing their important role, I think, towards that movement. And first part, when you go to the radio access, and I'm sure it has been covered, but I'll just quickly cover that, is that initially the RAN was pretty proprietary, but then as part of this 5G, and as thanks to ORAN, it has been divided into three parts now, the radio part. One is the RU, which is the radio unit, which is the antennas, and that of course has the antennas, and that would be very vendor specific. But then the L2 and the L3 processing of that, like the L2, I mean the layer 2 and the layer 3 processing, is divided into two parts. That is the DU, distributed unit, and the CU, centralized unit. Now, instead of doing that on the hardware anymore, it can actually be done on a cloud, on off-the-shelf hardware, like any servers. You can do that. In fact, that is where it is moving. So you have the radio antennas, which are anyway required, which you will be putting, but then you can run most of the baseband processing, the DU and the CU, on the cloud itself, or run on a software. Sometimes you may need some acceleration specific, but those are already available on the off-the-shelf hardware now. So I'll not go to much details about the CU DU. I think these are already covered or would get covered. The next part is that when you talk about 5G network, there are three parts to that. One is the radio network, I mean the one that I showed you. Then there is a transport network, which is basically sending the radio signals to the centralized core. Like if you are talking about Bangalore, you will have like maybe 10,000s of radios, and they would be connected through a fiber or microwave, and connected to a core network within a data center in Bangalore from one of the operators, where the 5G core would be residing. So now the 5G core earlier was pretty much that, okay, you have to buy a hardware for that from OEM. But now even the core is divided into two parts. One is the control plane, which is the AMF, SMF. These are 3GPP standard-based functions, and this can run as cloud-native functions. In fact, it is running as cloud-native function in by some of the OEMs is already available. And all these functions can actually be running on the cloud, centralized cloud. And then you can provide a local breakout for your data plane. In fact, the data plane also can be on the cloud, but to enable better throughput, you can also have a local breakout using an UPF, which is the data plane function of a 3GPP, and it can also run on a cloud, like a edge cloud, or it can run on a normal server. So even the core has got disaggregated from to be running on a cloud. And in between the 5G radio and the centralized core, you have a transport network, which can be a fiber, or it can be a transport network using routers, etc., which are also getting disaggregated. Because I talked about the data center routers, right, where a lot of movement has happened already. So the same routers, disaggregated cell-side router, front-haul gateways, they are also looking at a disaggregated solution. Now, because it's about open source, I definitely have to cover some of the open source which are available software. And when you talk about RAN software, which is an important part, there are open source available from Open Air interface. It is from Eurocom. I think Professor Chandamurthy was also talking about that. There are some open source available from TIP, from ONF. You can look into that for SDRAN, etc., for the ORAN part. ORAN also provides an open source that they're building for the ORAN part. Now, in the core software, you have Magma. Then from ONF, you have the free 5GC. Again, Open Air interface also has a open source 5G code that you can work with. Second part, the third part is basically you need to create an edge infra. So Linux Foundation has a lot of them. I'm not covering that, but predominantly Kubernetes is an important platform which is open source. You can use that. Lot of work is done on ONAP, Then recently, Nefio is a new edge cloud which is coming up. So for automation of 5G that you can look into. Lastly, the application. Again, we are not in that field. We really are not working much on the application. I've just put a couple of applications like OpenCV and Versadia, but there are so many other open source applications that can be used to create the edge cloud and various applications, Metaverse or IoT, etc., which maybe you guys would know more than me. But I mainly focus on the infrastructure. So, but I thought I would give a highlight on some of the open source which are available. And this is also some of the foundation to start. I talked about Neural being started with disaggregation and openness into mind, but we also use a lot of within our base infra. We use a lot of open source. Our Neural OS is using a lot of foundational open source to build on top of that. The 5G and the edge market is a huge market. I mean, if you see, it's a $517 billion as part of KPMG. But you have to see some interesting stuff here. It is just covering 3 industries. Industry 4.0 or industrial manufacturing is probably 206 billion plus, maybe part of energy monitoring is also part of industry 4.0 and intelligent transport. So overall, it's around $240 billion. But the interesting part is the gaming, the AR metaverse that we are talking. So retail or like gaming is going to be a huge part of that, and it's going to come up in a big way. It's almost a $240 billion. It would be on the retail and the enterprise segment, but gaming as a whole would have a lot of metaverse play. I would like to end now by giving a little bit of introduction about Neural. I'll run it quickly in the interest of time. So what we are doing is we have built Neural OS, which is a network operating system. We have 3 key components. We have the 5G core. It is a cloud native 5G core, which has the AMF, SMF, AUSF, all of them, which is needed for a private 5G deployment. It runs on any off-the-shelf hardware. In fact, it can run on your existing servers in your office. Then we have an edge cloud platform, which we call the Neural Edge Cloud, which is a Kubernetes and platform with VMs. We create a platform on top of which your third-party applications like robotics, drone, etc., can be running. And lastly, we have a centralized controller through which you can manage multiple 5G core and edge cloud remotely. And it is a Release 16 compliant 5G core. This is how it looks like when it's deployed. Our centralized core controller can be on AWS or any cloud, but in each side, you would need the radios, which we would get disaggregated radios, which we can give from our third-party vendors, or you can also procure that. And these radios get connected to our 5G core. And on the 5G core provides a local breakout to the edge cloud where your edge applications are running. The edge cloud platform is also hosted by us. In fact, our 5G core is also running on the edge cloud. Plus, you can run your existing edge applications that you want to host, like AR, VR, drone, etc. And it will ensure privacy because you are using your enterprise private network. The firewall, the DMZ zone that you are using your enterprise would be reused here because we are not connecting to the private network at all, except for, of course, connecting to the internet, like for the controller, etc. We also integrate our 5G core with the TSP core, like for example, that operator, if they are running their TSP, and if we jointly work with the operator, they can run the centralized core and run the control plane function like the AMF, SMF. And within the enterprise, we run only the user plane to provide the local breakout and run the edge applications that can be run. And so we coexist with the operators network. We can easily run that. So these are the flexibility of openness and disaggregation, right? Similarly, you can use our 5G core UPF and run it with the edge cloud, which is not ours. It can be a third party. It will seamlessly work. We have recently been awarded one of the award for 5G innovation. And I think this is a POC. We have done some indigenous end-to-end integration with a company, radio company in India, so we can provide an end-to-end indigenous 5G. And this is a POC running in one of the site where the CCTV cameras are, and this is the edge cloud on which our 5G core and the edge applications are hosted, and this is the output from the. This is one use case like of that. Yeah, with this, I would like to end the presentation and happy to take any queries later on. Thanks for your time.
Thank you, Abhijit. It was quite detailed. In the interest of time, I will hold the questions as we have a couple of more sessions lined up. But it was quite detailed. Thank you very much. And it was interesting to see the open source journey and the way NIRL has started.
Sure, thank you.
Thank you once again. So with this, we will be entering into the new segment of the today's event. That's the virtual showcase. To start with, the first one is about the predictive closed-loop automation for ORAN-based network slicing. Here, again, it's around ORAN and some spice of ONAP. And of course, since we're in Metaverse event today, we're going to see something about the AI and AR slicing. To demonstrate this thing, I would like to invite Mr. Joseph and Dr. Sukhdeep from Samsung.
Yeah, hi Dwarka.
Yeah, over to you guys.
Yeah, thank you, Dwarka. So hi everyone. So we are here to present our one of the latest research work, predictive closed loop service automation ORAN based network slicing. So before jumping onto the slide deck, I would like to acknowledge Virginia Tech US, who has been our collaborators in this research work. And in this demo, we will try to first set the context with the current trends, and followed by setting of the problem statement, the proposed solution, and then the demo in the form of captured videos and the slides. Okay. So here we start. So as we know that 5G or beyond 5G network is very critical for the realization of Metaverse. So in order to realize the Metaverse, we have like key 5G features enabling the Metaverse. One is the standard bodies have accommodated URLLC services in the 5G networks by including the requirements like latency reduction and increase in reliability. Okay. On the other hand, we have provision of network slicing. There's the net standard bodies have included the concept known as network slicing. So network slices are the logical networks that are provisioned with a set of isolated virtual resources on top of a shared physical infrastructures. Okay. And currently 3GPP release 17 standardization activities on RAN slicing envision that to empower the 5G network slicing as a tool that operators can use to open up new source revenues by involving the application providers in customization of 5G wireless design for the better support of the applications, and like for example Metaverse itself. So next is like since last 3-4 years, and as the first fellow speaker Karan also have pointed out that since last few years we have seen tremendous increase in footprint of open source projects. So particularly in telecom also we have seen a lot of open source projects or open source communities which are coming up right away from the enterprises to open access, open edge, core, and even the other edge activities. So this is a beautiful picture which we have taken from the Linux Foundation, which tell us what are the famous open source projects in the telecom in the different areas. Okay. And so a lot of complexity is there in the 5G to cater the diverse 5G resources. So use of these open source projects or open source communities has helped in reducing this complexity which 5G like has to cater for the diverse services, so that the developers or the design people can just focus on the business logics. Okay. And coming to the problem statement, so we have seen the network slicing as a key enabler for for 5G networks and open source as one of the growing trends, and both can be amalgamated to realize a lot of network to solve a lot of network problems. Okay, so here is one of the scenario which we have taken, like so for example, there are two metaverse slices. Maybe you can term as one as a Samsung metaverse slice and another as a Microsoft metaverse slice. So generally nowadays it is like there's a static allocation of the resources for both the slices. So in case of there's a situation where one of the slices we don't have much users, one of the metaverse slice is not having much users, and the other slice is loaded with the users. So currently we don't have the system in place which can automatically and intelligently detect such kind of patterns wherein one slice has underutilized resources and other slice has overutilized resources. Okay, so we have to balance out the resources between both. Okay, so so we have taken ORAN architecture as a base. Why? Because ORAN provides us the plug and play kind of architecture. It is based on the principles of intelligence. It can assist providing predictive and closed loop service automation by intelligently and dynamically orchestrating resources over the slices and maintain resource isolation as well. Okay, so the plug and the play model of ORAN, we can host independent applications to solve many such challenges in the network. So here we go with our proposed solution. So we have taken taken help of ORAN architecture and implemented our idea of balancing the network resources between amongst the slices using the ORAN architecture. We have built the kind of application for that. So in this kind of setup, what we have done is we are collecting kind of slice level data from the DUs, and also the cloud related statistics from the OCloud. So okay, at the slice level, statistics are collected over O1 PM interface, and the cloud related statistics are collected over O2 performance management interface. And from this collector, it goes to the our AI server. Okay, so in AI server, what we do is we clean up the data, we process the data, we clean up the data, and we train the data. Okay, so once the data is trained, we used kind of two machine learning models. One is the concurrent neural networks, and other is the LSTM. Okay, deep learning models to predict the future values of those KPIs. So once this training is done in the AI server, it will send the trained models back to the predictive closed loop RF, which is part of non-real-time RIC. Okay, non-real-time radio intelligent controller. So what it does is it will predict, based on the training model, it will predict the future values of those KPIs, okay, of different slices in the network. So based on the predicted values, it will be passed on to the near real-time RIC. Okay, so near real-time RIC will assess, it will make the policy based on which slices are overutilizing the resources or which slices are underutilizing the resources. So based on that, it will dynamically adjust the resources amongst the slices, and through E2 manager or over E2 interface, it will pass those policies and it will regulate the resources based on the policy which is made by the near real-time RIC. Also, the cloud resources, which I was talking about, which we have collected the statistics of the cloud resources. So the future predicted values of cloud resources will be done at the PCL RF itself, and through SDN we will try to push the policy to OCloud to optimize the resources based on whatever slices we have optimized. Okay, So over to my colleague Joseph, who will be sharing his knowledge on the live demonstration. Yeah, over to Joseph. Diwakar, can you please unmute Joseph?
Sure.
Hello? Hello? You can hear me?
Yes, Joseph.
Yeah, okay. You can see me as well, I think. Yeah. So let me share my screen. So I'll continue from where Subdeep left off. So the
Joseph,
slide
there is an echo. Maybe one of you have to mute yourself.
mute. Okay, sorry. Thank you. Yeah. Now it's okay?
Yes, Joseph.
Yeah, okay. So you can see my screen as well, right? Yeah, okay. So yeah, so Subdeep had mentioned about the overall architecture of how we implement closed loop automation. So I would be covering the part how it is kind of really realized using different open source components like ONAP, Akimos, and other open source components like ORA and SC also. So I would just go over the detail of that, and then I would show a pre-recorded video of how the demo and how the internal communication flow works. So, so looking at the overall previous architecture, right? So you need to collect the data. So for the training, we assume that the data in our demo is located in a data lake, a DB. We had used Cassandra DB. So we have stored the data in the data lake, and we use a data broker, which can communicate with the data lake to retrieve the required data for the training. And for retrieving the required data, we have a user interface where we can configure what features we need. For example, for different use cases, can configure different features. So for network slicing, we would then configure the slice level features that we need. So we configure that here. So it retrieves the corresponding data from here, and also we provide the for prediction, right? So we for training model creation, we need to provide the required hyperparameters that we need for this particular use cases. So here we are kind of predicting in time. So we kind of give the model algorithms that are required for time series predictions and the corresponding hyperparameters. So that's what we give here as input. So then the data broker retrieves it and then provides the input as a CSV file which has the data and also the required inputs for training. So we have different set of microservices here. So one of the microservices would actually read the CSV file along with the configuration and train the model. And once the model is created, it kind of generates a model in a format that is required by the Akimos server. So the Akimos server is mainly used here for onboarding the model and publishing it in a marketplace catalog. So it can be deployed in the that's how that works and how we retrieve the data and how we generate the model and publish the model. Once the model is published, you have a dashboard on ONAP which you can use to connect to Akimos and select the model that you want and trigger onboarding. So when you trigger onboarding, there's a set of process that runs. For example, it creates metadata required. It creates a Docker image based on the inputs and the metadata provided as provided during the onboarding. So once that is generated, so the Docker image is stored and also the metadata. So now we have the DCA GUI in ONAP, which would where you can design your application, how to deploy it. So you can select the Docker image, you can select metadata and configure it, and other parameters you can give here, and you can trigger deployment of the model in a form of an RApp, which is essentially a microservice which is running in Kubernetes, like a pod. So that is this final application which gets generated at the end. So this is the complete flow of how you do training and then how you deploy the model as a pod. And this exposes interfaces. So when you're configuring here, you would mention where you kind of want to retrieve the data when the model is running. How do you retrieve the data for inference or prediction? So that also gets configured during this step. Yeah. So going forward to the next step, once the model is deployed, then the remaining flow happens. So the model is expected to do prediction for a particular slice and for a particular KPI. So you predict some time series data in the future. You kind of predict its KPI for a particular slice. That's what the model would do. So for the model to work, you need data, and the data is generated by the E2 nodes. The E2 nodes are like a CU or a DU. So in our case, it would be a DU, which is we are using PRV utilization as a KPI. So the DU would generate it. So that would be generated here, and we are using some of the open source components. We are not using a real node here. We're using an emulator which has multiple components, which generates the data, and the data is generated for a slice, right? So if for a slice, so the data will be generated only when the slice is created. So we also have this framework in ONAP which helps us creating a slice, which you can see here. So all these yellow parts or boxes are components that are involved in slice creation. So we have a GUI in ONAP through which you can configure a particular slice and deploy it. So when you deploy the slice, it goes through all these components. It creates a network slice instance and deploys it. So these are all the management entities which are shown in the yellow color, which would be involved during the slice creation. At the end of the slice creation, there would be a command or a message that goes on the O1 CM interface, which is used for configuration management onto the E2 node where the slice needs to be created. So when the slice is created here, that's when you kind of generate the data. So this triggers the generation of the data here for that particular slice. So if you create another slice of slice 1, when it is created, it generates the data for slice 1. When slice 2 is created, it generates the data for slice 2. That's how it works in this demo. So once this data is generated and it is collected here as part of the SMO, this is provided to this RApp or this ML model application, which predicts the future data points. So that's what this RApp would do based on this data inputs, and it would then decide what to do with this data. So some kind of mitigation action or a policy that will be provided through this A1 interface. So A1 interface is used to configure the applications that are there in the near arteric, like Sukdeep had mentioned those. This is the non-arteric which is there in the SMO. This is the near arteric which would be which is part of the it's just nearer to the RAN. So this would perform this entity would actually perform the configurations towards the RAN. So based on the prediction, you configure some policy. The policy comes to the XApp, and the XApp would then decide based on real-time inputs from the nodes. It would decide how to configure the resources in this node. There will be a lot of nodes here. For example, under one near arteric, there would be few thousands of DUs. So that's how the entire flow would work. When the slice is created, the data is generated, prediction happens, and a policy is configured, and the final configuration happens on the DU node. So this is the complete closed loop flow that would happen in runtime. Yeah, so so most of the components here are open source. So ONAP is one major component here, and then the NearRT rig is also another open source component. And in the previous slide, you have seen Akimos, which is used for publishing the models, so that is also open source. So most of the components are open source, and this demo is kind of showcasing how all of these are integrated together to show an end-to-end demo and flow. Yeah, so maybe I can go to the video. So the first video is the first flow, which I had mentioned, that how the data is taken from the data lake and training happens and it's onboarded and deployed. So this is the flow. So this is the application. It's a simple Python application which we have developed, and it takes the input, like we mentioned, the data from the data lake and the configuration files that are required for retrieving and training the data. That's this flow. You can see that training happens. We're using TensorFlow, and at the end you would see that once the training is finished, here we are using very less number of efforts just for the demo. All that can be configured in this configuration file. So once the model is created, it is published to the Akimos server. So once it is published to the Akimos server, the model is onboarded onto the Akimos server. We can see that in the Akimos GUI. So the Akimos server has a GUI. So this is the Akimos GUI, and you would see our model name was cell 15 prediction model v5. So it is not yet there. So now it is uploaded. So it would be automatically uploaded from the Python code using the Python SDKs provided by Akimos. So once it is loaded, then you need to configure, give certain parameters, license profile for these models, and then publish it. So that's this configuration that is being done here. So you'll have to give all these parameters before you publish. Yeah, so then you can see that at the end you kind of confirm it, and then the model will be published. So once the model is published, then you can go to this is the NIFI GUI of ONAP of TCAE, where you can design your application. So this is what I mentioned here in this slide. So this part is completed. So you've published in Akimos. So now this part is starting. This is where the next GUI we open and then try to access this model that we published. So this is that step where in the NIFI GUI you kind of select Akimos, and then you select the URL where it is published, and you see that model is there, and then you click onboard. So once you onboard, you go into this step where this Docker image is generated and it's uploaded to Nexus, and a metadata is generated. After that, you in the DCA GUI where you design the application, you would be able to see the application which you can use for deploying it as a pod. So this is the step where it is. Yeah, so this is the step that you're configuring, and your flow is distributed successfully. At this point, it's all uploaded. The image is created and the metadata is configured. So after that, then you can log into DCA dashboard where you can see the blueprint of the model that you onboarded. So this is what you can see here. And then you need to configure certain inputs here so that you can deploy it where you actually deploy it as a pod. So because you need to configure where you would get the data from. So in our case, since we are using ONAP, you would get the data from DMAP. So you see here the best generator generates the data when the slice is created. After it's generated, it would publish it to the DMAP, which is like a message bus where this RAP would subscribe to a particular topic and retrieve that data. So that subscription needs to be done in this configuration step. So that's this part here where you subscribe URL, where you provide that best collectors output. After that, you will deploy. So once you deploy it, you would see this a pod running as part of the cluster. You would see a pod with the similar name of the model, cell 15 prediction model V5 running. So this would expose this would subscribe to that particular topic which we mentioned during deployment and wait for data. That is the step. So now, so the pod is ready for predictions now at this point. So the next step is the slice creation, which would trigger the data generation part. So for that, you need to go to the ONAP GUI. That is the next video where you actually create the slice. So you can see different tabs here. So this is the RAN NSSMF, which is also part of the flow. So this is the WES generator, which is waiting for the slice to be created. So from the ONAP GUI, we have to create the slice that we require. So this is kind of creating the communication service, and then the network slice creation. So these are all logs that and messages that are getting exchanged between all the management interfaces in ONAP. So yeah, so this is the flow. So this is where it gets created, where you give all the parameters of the slice. And yeah, you can see the finished message. So at that point, you can see the predictions start happening. The slice becomes active in the WES generator, and the data starts generated. So you can see this new measurement report created in the WES generator. So the WES generator was waiting for that slice to be created. After that, it starts generating data for that slice, and then it will do the policy. It would do the predictions, and then put the A1 policy, like we saw here, this step, into the A1 mediator. And then this is the XApp. XApp receives the message, and this is the E2 SIM. E2 SIM then receives the final configuration message on the E2 node. So this is the complete flow, and these are all the messages that we are showing it, how it happens internally, and how all the messages are exchanged. Yeah. So so that's about the demo, the complete flow. Yeah. So if there's any questions, we can take it.
Thank you, Joseph. Thank you, Dr. Sukhdeep. It was great to see this kind of a fancy item actually in the working state. Most of the things in the slide, they look nice, but it's difficult to have it in a working model.
Right.
So it was recorded, but thank you for showing that in the action.
You're right. Yeah.
Thank
you.
So in the interest of time, we'll take the questions offline. If anything, we'll pass it on to you and we can answer the
sure.
separately.
Okay. Yeah, sure.
Okay. So we'll move to the next session, which is again in the virtual demo side. And I would like to invite our veteran, Mr. Subodh. He has been in multiple events. I think most of you must be knowing him and seeing him in different occasions. So welcome Subodh back, Principal Architect at Cisco. Today Subodh is with something new called FSO, Full Stack Observability. I'll let him explain. He's an expert than me on that topic. Thanks Subodh, though I know you have been traveling a lot. Thanks for your time.
Sure. Thank you, Dwarka, so much for providing me this platform. Just a quick audio video check. All good? Can you guys hear and see me well? Okay.
Yeah.
Okay. All right. Thank you so much again, Alok, Dwarka, you, Chengappa, all of you folks for providing this platform again. And I thought, what a beautiful segue from what Joseph and Sudeep shared earlier, and also my colleague from Viral, right, Abhijit. I thought while we talk about 5G, enterprise blockchains, or even the advent of AI/ML frameworks, everything in 5G is an evolution, right? So, for example, between release 15 and 17, you find so many things being done. People are talking already about access, transport, and core slicing. And when you now introduce all of this to a final thing of what are we doing with this really, right? So I speak to a lot of customers in my role in Cisco R&D. It's all about designing solutions not aligned to a platform, but more really to the business context, right? And one of the phenomenal needs is everyone talks about is full stack observability. And I thought, let me use this next 22 odd minutes, and I'll slice it in this way, maybe just a talk for the first half, and then a demo about what this all really means. And it's actually a live pod setup, which I was just setting up since today morning. So let's demystify this, right? As Dwarka said, what does this mean in the realm of enterprise blockchains of 5G? And now suddenly I'll request all of you to wear the lens of blockchains or 5G more as an infrastructure, but what rides on them, let's say when you look at a private 5G setup for a healthcare provider, let's take, let's say Manipal Hospitals closer to home here, or let's take Fortis, Wokhart, or let's take a Starbucks or a Walmart, or let's take ISRO or DRDO. Ultimately, when you provide them a network and an infrastructure and hybrid or sovereign clouds, they're looking at hosting apps, right? So applications are like, they are just the front door or a revolving front door. And what they really achieve is behind for people like us. So let's say maybe Dwarka and me are responsible for the infrastructure. Like let's say Chengappa and Abhijit are responsible for the apps. There's someone else, say, speaking a name here, say Sudipta, right? She's responsible for the security part. There is someone else for the IT part. And now you see where I'm going. So we have this world of, we have people who manage stuff or infrastructure, but again, they are in silos, which means the security, the IT, the network, the cluster, the security, the application guys, they are not having this context. And now when you say an end-to-end 5G or a private 5G slice, how does that transcend and give me the complete observability? Sorry about that. Let me grab a sip of water. So in the realm of observability, I think the simple premise is how well do you know the internal things of a system, whether it's a router, a switch, or a controller. And yeah, it's a simple concept that if you see more, you'll observe more, and you'll get better insights. So this is where I think the industry of DevOps, NetOps, and all the principles guiding them is moving towards AI ops, right? I've just mentioned names, but for today's demo and talk, we are looking at full stack observability. So we start from the physical infra or the network or whatever we call as a network. Then we look at the applications. Then we look at why they're designed that way and what are we trying to achieve with FSO. And this would be probably the most rudimentary block or brick of this vision for AI ops, right? As we now bring cognition, or we change from CNN to ANN, right? From conventional to really artificial neural. If you do not have that full stack observability, you're probably going to risk violating the basic principle, and which is like you're trying to find that keychain in a room which is very clean and nice, but it has probably 500,000 places to look. So if you don't know where to look for what you're looking, how will you ever find that thing? And full stack observability is all about narrowing down to that issue. It's no longer an operational concept, although it started from there, from the IT ops and the DevOps people. So welcome to the web scalar world. Right? I don't need to tell you the manga, the metaverse, all of them, right? And now the cloud itself has become the new silo. For example, the public, private, or the hybrid, or the sovereign clouds. As you embrace a hybrid or a multi-cloud solution, whether you're a bank, a mining company, just a smart connected city, or anyone else, you simply are actually adding layers of complexity if you do not understand where to look and what to look for quickly. So the full stack observability, if you're watching the screen, is really about bringing all these domains of, if I'm to use the right word, functional attributes, people who do stuff to infrastructure, network, application, security, and then achieving something very closely, right? So I think that's pretty much what I had on the slides part. And in the interest of the demo, if you keep this in front of you and just remember these words, like I've just given a few use cases we are trying out in the labs, and for today's talk, I'm going to demo something what is called as I would say hybrid application monitoring. Let's take that, right? And I thought it just makes sense. Let me annotate this if I can. So this is how it will look like. Okay, so you have a network, infrastructure, and then applications riding on top of it. And let me start building that. Let me see if Dwarka, please let me know. I've just changed my sharing options to screen now. It will be slightly heavier, but let me know once the demo pod comes up. Can you see that?
Yeah.
Can you see a timer for 7 hours?
Yes.
Okay, thank you, Dwarka. All right, so we are just going to launch something called as hybrid application monitoring, right? And in the interest of time and in the interest of relevance, I thought let's use something which is very close to, let's say, a coffee house or something very similar to a Starbucks model, closer to India for folks who are from India, or for folks who are outside, imagine Starbucks by itself. And that makes perfect sense. Okay, let me see why this container is slow. And the model, meanwhile, as it comes up, let me just show you. This is the model, right? So on premise, let's just call this Indian tea house, or just tea house for short. On premise, I have an intersect Kubernetes service, and this is the application. So imagine all 100 of us right now trying to subscribe or trying to order from our phones, our tablets, or maybe even our laptops to this coffee house. It has an obviously a cloud component which goes to, let's say, AWS S3, and there's a linkage, as you can see here, to an external payments gateway. So this is the topology, simple topology, just like a tea or coffee or a Starbucks delivered on the cloud. And all right, the pod is up here. Okay, so when I say hybrid application monitoring, right, and this is through an app, what we call as App Dynamics. This is my container here. So this is how the applications will look like. So in a nutshell, if you're watching the screen closely now, you'll be able to relate with, okay, in my tea store, I'm running this tea store, maybe 100 of you are at different stages of placing the order. Look at my revenue at risk. So it has to compute at real time. You cannot have, for example, user number 55 waiting for user number 45 to complete his or her transactions. So this is a ready reckoner. This is what full stack observability just for the ordering app looks like. So I may have 64K of revenue, but out of that, almost 80% or 52K is at risk. And this is why, all the applications going through, so I can narrow down on this. These are the dashboards it will talk about. So this is the way applications sitting on top of network I need to look at. So you can say double click on this app. Let's say, why is it showing me this? And I hope it's coming up in the right time, but it should be able to tell you now at the app, when you're saying app, the session, presentation, and the application layer, my friends, we're talking UDP, largely UDP sockets and Quip, right? or TCP sockets. And that needs to be translated to the network layer, which is again VLANs, IP addresses, subnet mask, VPI, VCIs. So it has to delve and tell you exactly where the application is reading. So now you can go down and look at, say, my business transformation or business transaction health. The health of my database on which this is hosted. So if this was on a Kubernetes cluster, you would like to know why this is happening, how many calls were made. And last but not the least, this is the complete, as of now, maybe for 100 of you users ordering tea, coffee, how are the applications behaving? So all of this needs to be first shown as a dashboard, and then maybe we can go to an app. I'll again go to the T-Store app, and at different stages of my Kubernetes cluster, what goes on, right? So the red one obviously is in the premise. This is my in-premise one. And it's showing me completely what's going on from an HTTP or a TCP perspective. Okay, I had 108 calls per minute. So roughly we're talking about 18 millisecond asynchronous loading time to the server. This is my application response. This is the way, there is some issues with it. There could be some more issues with it. And if I had to troubleshoot any of this transaction types, what would go on? So the first premise of full stack observability, my friends, as you go through this is, can I get visibility on my applications? Then can I come down to the servers and really look at, are there any servers which are having some issues? Can I look at, for example, what kind of containers did I launch? Did any of these containers spike my CPU up, right? So could I go here and look at just this container, this application performance monitoring, and what did go up, what did go down? So the real estate consumed by any container, right, on the guest OS would be CPU, memory, network, disks. If you don't have the ability to look at what's really going on from a memory or a memory fault perspective, or simply is the garbage collection happening on time from an application perspective, was there something missing out? So a lot of things in this premise of application monitoring, right? And this is what will I think launch when 5G now, as we are very close, probably I think less than 2 weeks away from our government really taking a call from a spectrum perspective. Just imagine fast forward maybe 8 months or 1 year from now, you're potentially looking at so many of this private 5G or public 5G networks, or even shared spectrum users or applications having this kind of visibility. So in a sense, full stack observability, again, just to repeat, is really about getting your DevNet people, the application people, the IT folks, right, which houses the infrastructure, and your networking folks working together to really give you this observability, insights, and then the actions. So actions would be very directly uncorrelated, right? If this is the way my revenue is going to take a hit, then I need to know very clearly what's happening. I can pick up any of these alerts. So I'm not saying all of our 5G phones will need to have this kind of dashboards, and this is more of a lens inside someone like a Reliance Jio's NOC or a provisioning center, or any private, so let's say TCS or Wipro apply for spectrum directly from the government, assuming private 5G opens up, then this is the dashboarding view they would need to have. So this was really a nutshell, and this is just probably 1/50th of what hybrid application monitoring is all about, with the premise again of we had this kind of a Starbucks or a cafe coffee day kind of an example, but this is how it would look like, irrespective of whatever is the architecture below, whether it's a 4G or 5G or an enterprise blockchain. This is how it would look like. I'm not sure if I'm good on time, but I'm happy to take any questions. Chengapa, Dwarka, if there's any questions in the Q&A panel, or if any more screens, or any more open-ended questions from anyone.
Thanks, Subodh. You're very much on time.
Okay, wonderful. Any questions?
You actually saved panel.
Oh, good. Yeah, I remember they had to kick off at 5, right? So just want to be sure. Yeah.
Thank you. Guys, we
All right.
have 2 minutes, so we don't mind if there are any questions for Subodh. We can take that now.
Sure.
It's quite interesting demo, Subodh. I didn't expect this to be in action. So far, these things have been on the Wikipedia or somewhere else in the mind.
Yeah. No, it didn't take long to set up this, but you know that just writing that application to make sure it's very thin, that just took a little while. But I'm very happy I could show this, and I'll keep again this screen before everyone if there's any questions. But yeah, these are exciting times, Dwarka. Really, just in the context of everything that's going on, and especially 5G and what kind of LLC apps or even MMTC apps it will usher. I'm sure a lot of our smart cities are going to demand this full stack insights and actions.
True. So just one thing out of curiosity, when you said you have had a fresh application development, so what kind of programming language and which platform were you using it?
Sure, yeah, absolutely. So I prefer Ansible. It's more declarative than the imperative one, but you're welcome to use anything. So Ansible with RESTful APIs, and most of, I think every gear in Cisco, and I think every of our competitor too, everyone now uses REST config and net config. So whatever goes to the network device port is net config. Whatever goes to the services layer is REST config. So a mixture of Ansible as the orchestration layer. The modeling language is called as YAML, yet another modeling language. It's an IETF RFC. And net config, REST config are also RFCs now. So these 4 are pretty much, you can do anything in this, absolutely anything.
Great. Thank you very much, Subodh. I think we are dot at 5. I'll not hold our 6th panelist. I'll let them open the stage. Thank you very much.
Sure. Cheers. Bye.
Thank you. So we reached to the last session of our event today, and most interesting part of it, where I believe even existing speakers must be awaiting for that. That's a panel debate. We have 6 industry esteemed leaders. Let me introduce them. We have Ms. Gandhali Samant, Director from GitHub. We have Mr. Vinayji Rajgopal, Technology Lead from Red Hat. We have Dr. Sumit Kalra, Assistant Professor at IIT Jodhpur. We have Mr. Syed Mohammad Qasim, Senior Manager, Texas Instruments. We have Biju K. Nair, Founding Partner, Legally Tech. And Dr. Lokesh Boregoda, Doctor at Samsung Research. So panel, over to you.
Thanks, Dwarka. Can you hear me?
Yes.
Yeah, thank you. So this is great to be over here with such a delight panel. I think we had some great presentations in the last 2 hours. And the interesting thing is many of the speakers made our life pretty easy. I picked 1 or 2 points from each of them, and they're very interestingly guiding towards what we have been thinking in terms of discussing and debating here today in the next 1 hour. I thought I will just flash the a single slide about Metaverse components, and that will actually start the whole game. So let me just confirm if in case you can see my screen. Are you seeing the presentation?
Yes.
Yep. So are you able to see the presentation?
Yes, yeah.
Yes, it's visible.
Okay, fantastic. So if we look at quickly in 2 minutes, the Metaverse is a magnanimity of a whole bunch of technologies. So if you look at the whole Metaverse value chain, so from virtual worlds till interfaces, IoT, blockchain, MEC, cloud, network, AI contributing to it, a whole bunch of things coming together for the sake of creating this wonder world called the Metaverse. And what is important over here is these 4 aspects, what you can see: the virtual spaces, virtual assets, virtual interactions, and digital payments. So I'll just stop sharing. I just wanted to bring this perspective basically. So if you look at the Metaverse space, there have been a lot of attempts. People have started looking into what Metaverse can do and how we create the metaverses, the next new revolution. Now, in this whole context, if you see, there are a bunch of technologies that are required. It's not one single technology. No single player can actually have everything under their roof. So that's where the open source aspects come into picture. And we would require a whole bunch of partnerships, a whole ecosystem to be created for the sake of enabling this. Now, given that context, definitely open source will play a huge role in this. Now, if you look at the points mentioned by some of the speakers, for example, when Karan was talking, he mentioned about the whole experience, and he made there was a statement that fast is better. Now, this open source is going to facilitate this metaverse kind of huge entities come up faster. So that's one of the main things. Also, he emphasized on the documentation, which is very clinical when it comes to the open source components, and that's what really helps us go forward. So that's where the open source community can bring in a lot of things. And going further, there were many points which Rishikesh brought up with respect to the user data and in terms of the privacy aspects, confidentiality aspects, which need to be really taken care when we go to a whole space like a virtual space like Metaverse. Now, I have some great speakers here or experts here who have been raring to go to enlighten us in the next 1 hour or so. I would be throwing out a few questions at them. So we have, as Dwarka mentioned, the 5 panelists along with me. So one of the main questions that I would throw to the panelists for the sake of opening up this whole discussion is the metaverse trend has already caught the imagination of all global technologists, and everybody is into this. Researchers are trying out a lot of things to actually make this a reality. So given the width and breadth of these technologies for realizing an aspect such as an entity such as metaverse, many open source contributions being taken into it would actually have huge implications, and they would be very significant. They will be playing a very significant role. Given this context, what is the opinion of our panelists with respect to the role of open source, the related implications, the complexities in the whole span of the metaverse operation? So let's start with Mr. Vinay. Vinay, you can go ahead.
Thank you, Mr. Lokesh. Pleasure to be here. Always.
Your voice is very low. Can we?
Am I audible or it's still the same? Is this better? Still the same? Lokesh?
Yeah, this is better. This is better. Now it's better. Yep.
Okay.
Go ahead.
Let me be at the top of my voice. I'll see if I can get closer to the microphone as well. Is this better?
Yeah, now it's good. Yes, very good.
Okay, excellent. Yeah, so I was saying thank you, Mr. Lokesh. Pleasure to be here, and very, very glad to be a part of this panel alongside, my fellow eminent panelists. Let me start first with, congratulating Samsung and Red Hat on the backdrop of the announcement that happened last week. Samsung and Red Hat coming together to work on Linux drivers for Metaverse. It's given that the exponential growth of data-driven, be it AI, be it AR, or the fast approaching metaverse, I should say, is definitely bringing a lot of disruptive changes to the memory designs, right? Requiring more sophisticated software technologies that better link with the hardware enhancements. We've seen a lot of hardware enhancements, and it becomes very important for the software to catch up with those. Now, on that note, it's great to see Samsung Electronics, and of course, the world's leader in advanced memory technology, and Red Hat, the world's leading provider of open source solutions, announcing this collaboration specific to Metaverse. And like I always say, it's always good to get into a panel discussion at the backdrop of an announcement. So that's the best part of Metaverse. We know it's a reality. Now, you just heard me say Metaverse a couple of times. You probably heard from almost every speakers, touched upon Metaverse, right? So we've been hearing Metaverse quite often, than a lot more than ever these days, right? Whether you believe it, if it's a reality or not, the adoption of the term itself, if you hear Metaverse anywhere, has definitely signaled a very significant, considerable shift in the way we all think about future online interactions and online experience. And I saw that little slide that Lokesh had brought up, in terms of the virtual experiences, right? So for us as humans, the imagination is, there's never end for an imagination, right? Look at probably co-workers or students gathering for a coffee chat, irrespective of what part of the world they belong to, right? Look at musicians or artists who can now interact with fans from around the world in a large digital venue, which probably would be impossible in the physical world. And on the other side of the coin, right? If you look at the economic impact, the conferences can now reach newer audiences, never before, geographically distributed regions, and the amount of scale that it can reach, right? It's very, very significant. Now we know all for this because we are witnessing. You heard all the demos, you've seen all the speakers talk about 5G, AR, VR, the X apps. So the biggest drivers that we see here is the fact that we're witnessing a lot of technological advancements, be it 5G or AR, VR, or edge computing, right? All of this leading into what we call the ultra reliable low latency services. That's what ensures that the rendering of the 3D graphics, the rendering of the content in the virtual experiences are fast, and it doesn't impact the human brain, at least. Right. On that note, it becomes very, very, very important, and we've been seeing that. We've also been seeing the distributed social circles, the way be it pandemic or be it how we've been interacting in the human circles. It becomes very, very interesting for all of us to witness this whole seamlessly connected virtual worlds as a part of the metaverse. It probably has never been more appealing than now, but who knows, right? The fact is maybe tomorrow's IEEE Open Conference would be hosted on Metaverse. So that's how far we could go with Metaverse, at least. Now, the thing that if you heard at the beginning of the keynotes of the way at the beginning of the conference, right, Mr. Mohan Rao showed you that diagram of the different layers of Metaverse coming together. It becomes very important, and he stressed upon these points. It becomes very important that any platform for such, be it Metaverse or any others, right? It becomes absolutely important to adopt at scale and also be sustainable, right? Otherwise, they fall flat, and that's where interoperability, open source, like Mr. Lokesh mentioned, it becomes absolutely important. Now, we've seen, that's the concern that I probably have when it comes to Metaverse. But we've seen, it's not that we've not. We've seen some of the standards, these specifically open standards, which ensures interoperability, be it Razer's OSVR, the open source virtual reality semantics. We've seen that encourage experimentation of headset development and the fact that it goes all the way up the stack, right? Now, if you look at on the other side of the coin, at the device layer, we've seen OpenXR, the standard that has been widely adopted by headset manufacturers, which kind of allows applications and engines to target with a single API. Now, with the device-specific capabilities supported through various extensions through those APIs. So that's good part of it, right? Now, the metaverse, what we see as of now, most of us probably agree to that, is the fact that we're already started seeing a lot of proliferation of 3D environments, right? Often created by the users themselves, right? And that's where this whole blockchain becoming an imperative to ensure we all know who creates the asset, who owns the asset, and what is the transaction, and so on and so forth. But this use of this digital assets, or what we call avatars, right, and the incorporation on the virtual and augmented reality technology, this becomes absolutely important for us to kind of put them on immutable ledgers and make sure we understand who's built it, who's buying it, who's selling it, and so on and so forth. So these requirements as such becomes much more important from a legal aspect, from a transaction aspect, and of course with the technology enabled drivers and the computing paradigms, it's interesting how far we get and how far we were able to achieve that seamless aspects, right? And but what it also throws up is, despite of all these challenges, what it also throws for all of us is the fact that there is an opportunity for us in encouraging the development of decentralized, distributed, and interoperable virtual worlds, right? Built on, like everyone has already mentioned, built on the foundation of open standards, and that I believe very strongly would enable a circular ecosystem around metaverse, and most importantly, the adoption at scale. And those I think are absolutely important for the future course of metaverse.
I think that's an interesting word you coined, a circular ecosystem. So where everything is tied together. That's fantastic. I think I'm going to pick that point, the circular ecosystem. Yep. Thanks, Vinay. So over to Gandhali.
Hi, Lokesh. First of all, thanks for this opportunity, and it's quite exciting to be here with all these industry stalwarts. So, when I think about open source, in context of metaverse or also any other new age tech that we think about, right? The first thing that I think we all need to acknowledge is that open source being the kind of the ground zero for this technology development, and it has definitely become the preferred way of growing what we call hot new technology. Like if you look at the most popular platform in any I would say the technology domains have come forward in last couple of years or more than couple of years, maybe last 5 to 10 years, AI, blockchain, containerization, all the biggest projects or products that are being used or have been adopted are the ones which have been, developed in open source. And that's because open source has a great number of benefits. You can collaborate with the smartest minds from every corner of the world, and your work is constantly reviewed and used, and you have this constant feedback loop. You are connected to so many people, so in that sense also it draws a lot of parallels with metaverse, which is basically, in a virtual world we can connect with anybody. The physical bounds are no more there. And it's very easy when you are looking from open source perspective, right? Because if you say want to build an application or a service for the metaverse, you never would have to start from scratch. There always will be components or applications or whatever you need is already there. It's developed, and as metaverse is continuing to gain the traction, you will see the more and more number of tools and platforms that will appear to help the developers develop for metaverse. So to summarize, I think open source is already playing and will continue to play a very, very significant role to all the and innovation that will continue to happen in the metaverse space.
Thank you. I think that's interesting. One of the main points I can pick from this is the implication in terms of cost. So time is money. So you can actually ramp very fast with OS, open source, and then the connect to the experts globally. So that's the great thing, a great advantage over here. So thanks for those points. Yeah. I think over to Professor Sumit.
Yeah, thank you, Lakesh, for providing the platform and giving the opportunity to share my views. So all of us are, of course, agree in the favor of open source, and it should have been the way to go forward. But I would say there is a word of precaution. Of course, open source comes with lots of benefits like quick development, larger community which is contributing. So once larger community is contributing, they own the software, they own the entity. When the belonging comes, then the quality also comes. But in the history, what we have seen that in 2014, there was one bug detected in Unix shell. So that shell source code was open source for so long, and we don't know for how many years hackers were exploiting that bug. If it would have been closed source, hackers would not have access to the bug. So that is unknown part. What was the cost of that bug? Because it was there since 1980s till 2014. And so we are, if we draw the parallel between universe and metaverse, we are at the verge of creating Big Bang for metaverse. And if you remember there are microwaves which was generated 13.8 billion years ago, and they still exist in our background. So today, if we create that big bang for metaverse, whatever microwaves we are going to create, that going to exist and going to impact rest of the metaverse development. So with a word of caution, I would say we should go for open source, but then we also should adopt open standards so that we reduce the risk in the open source.
Okay, that's a very interesting point that you brought out. I remember when discussing with you, you were also mentioning about copyright aspects. We'll get to that later. So this big bang in this metaverse, just like our universe was created, I think that's a very interesting parallel that you're drawing. We need to ensure that these repercussions go in the positive note rather not on the negative note. So that's a very interesting point that you brought out. Of course, so we should have this cautionary angle while we are getting into this. So I would request next Qasim to actually go for his views. Yeah, Qasim. Qasim, please go ahead. Can you hear me? Qasim?
He's probably on the mute.
Okay. Qasim, you're on mute? Yeah, we can hear you now.
Okay,
yeah,
sorry.
thank you. We can hear you now. Please go ahead, yeah.
Yeah, nice initiative. Thank you. Thanks for this opportunity, for this wonderful audience, and discussing the open source, preparing ourselves for the next big thing that is going to happen to us all. So as part of multiple open source initiatives for last couple of decades in my career, like I have seen the evolution of open source starting from Linux, which was just to do in 2.0 or 1.0 time frame, to now where it is in the 5.x regime, right? So a lot of open source thing basically started for shared software development. So the cost for any company, for any organization, for any product, when you see the software cost versus the hardware ecosystem and the support and tools that comes around it, the biggest challenge for all of us is like the cost of developing the software. And to develop the software, you need a unique skill set basically. So that's where the issue starts, right? Like it's not like you start building software with a basic bare minimum thing. You need to architect it, you need to come up with the design, you need to identify the common pieces or components that you want to bring in. Then you really start the coding aspect of it, and then validation, then getting things into commercialization, and then business model, and then it goes into the hands of developers and the consumers and users of it. So it all boils down to like who is going to invest in the software and why me first kind of philosophy, right? Like that's where it all starts, and there is a limit for everybody to invest in software, and that's where they'll all say like, okay, my investment is only till here. Though we say open source, we know that there is no free lunch, right? Like somebody is paying for it. Now that's where it comes down to, like, it's not free. Open source is not free. Like free software versus open software are two different entities and two different things and terminologies. So when we say open source, what we are doing here is the enabling a shared software development model where we want to collaborate with similar entity which wants to invest in software development. We develop this part of the software and you develop from here, and the other party develops takes it forward from there on, and overall the ecosystem for that end use case gets built. So that's where it starts with, and the bare minimum and the fundamental thing is the hardware, right? Today we need the hardware to start developing the software. So first we need a low cost hardware which anybody and everybody can afford. So that's where the Intel ecosystem and x86 ecosystem really picked up, because everybody uses PC, and when PC is there, the software development and another investment on hardware is not necessary, so the software development happens on the PC. Slowly, then the embedded systems evolved, and then embedded systems took over some of the burden of software development hardware, and then the ease of using of the hardware and tools, those things evolved. Then the ARM ecosystem evolved. Similarly, when the mobile inventions happened, then everybody started building the apps for those mobile, and then Android came up, and then Android tried to stitch together all the components which are available in open source community and then made a product around it. So that's how it all starts and evolves. So to begin with, it's the basic foundation which hardware to go after. And today the hardware is not easy to program. The things have evolved so vast and so deep technically. Like even in a simple wearable watch, we are seeing multi-core architecture and multi-core programming and so on, right? Like even a simple device has become today a analytics-friendly device where some kind of smartness is expected in every hardware that we pick today. So therefore, the complexity of software development has evolved.
Yeah, it packs a lot of power in the devices, right? Yes.
Yeah. So to develop that software, you need very unique skills. And once you have those skills, you're not going to work for free, but you will definitely be interested to work in open source so that you contribute to the source, because you want to expect more things to, like in terms of validation or in terms of addition of new features or in terms of robustness, in terms of scalability, you will expect it. So companies, though their business model is different, they make money in some other places. For software, they want to have a shared software development ecosystem, and for that the ecosystem has to be built, and it makes and breaks every time. Linux is one good thing which has evolved for so many years, and it is consistently increasing, but there are so many other open source ecosystems which have failed as well because they were not able to sustain because of the business model that they were into. They are something which have not scaled up. Some concepts like Android, they have scaled to huge acceptability, right? So there are good and bad and pros and cons and scalable versus non-scalable, everything in the open source ecosystem. So when it comes to metaverse, now we need to, it's now the time to define like what is the hardware ecosystem that we are going to enter into, and what kind of software skill set are required, and where the community should be built around. Is it like a unique community, or is it leveraging the existing software ecosystem, or where we want to start with, and then how does it scale on its own, sustain on its own without money being pumped in from any big organization? Like, can it evolve on its own? So that kind of ecosystem has to be thought through, and I think once the business model aspects are clear, then I think it will evolve on its own. So this is my take.
I think this syncs very well with the point that Vinay was mentioning with respect to the circular ecosystem. So it's not just the software or the open source, it's the hardware as well. And how we're going to take this ahead is going to really matter. And how we're going to make it scale also really matters. I think we got a pretty good view from all of you. Now, one of the interesting aspects that Biju will bring in, I will probably request him to go ahead from the legal perspective, right, Biju?
Thanks, Lokesh. Thanks, everybody, for sharing your views. And thanks for the opportunity. So, as you all mentioned that the open source and metaverse creates great opportunities, and there are some issues like which Dr. Sumit pointed out, like the security aspect and the vulnerability aspect. And, at the same time, this also has various legal implications from an intellectual property perspective, unlike the traditional, universe. So courts across the globe are, contemplating and already seeing many of the litigations which people have trademark or any other side of IP in the traditional way, and people are using the same thing in the metaverse. And this also creates a lot of enforcement issues from the legal perspective. So IP, how businesses have to consider in the traditional ecosystem and in a metaverse would be quite different. So this opens up lots of challenges, opportunities also. because there is an opportunity for creating and safeguarding many of this IP in the metaverse. And business also have to think of how to protect their intellectual property going forward in the metaverse. So whether it is, going for IP registrations in the virtual world or having some sort of an activity in the virtual world, and also enforcing at the right time against infringers of their IP. So all this creates a lot of opportunities, problems. So it's an interesting time we are living in. And as regards to what Dr. Sumit said about the issue of vulnerability and stuff, I think the last 2 years, the whole globe has woken up to the vulnerability issue. Companies across the globe and Linux Foundation, everybody's, the US government, everybody is trying to spend more money on vulnerability detection and security, which is an issue which we have faced in the past. And I think going forward also we will face this issue. But I think as a community, if you work together, I think all these issues could be detected and patched up. So my thought
I think
process.
that's interesting. I think we'll probably more elaborate when you come to the specific questions. So I think you summarized very well the challenges that would lie along with going with this kind of a large scale metaverse building, right? I think I have some specific questions to all of you, if in case we can dwell a little bit deeper. So I would come back to Vinay. So Vinay, in your discussion, you were mentioning about the platform, how we are going to actually do the adoption and look at the scale aspects, and also about the open standards. Can you please elaborate further? What would be the criteria that would help metaverse organization with build metaverse to build such a platform, and need to be cognizant with all these aspects? And also, what are those important things which are very critical for such open platform going into metaverse? Vinay?
There. Am I audible?
Hello, Vinay. Your voice is not clear. Vinay, are you there? Okay, I think we'll get back to Vinay once he is back online. So, Gandhali, what are your views?
Okay, there. Yeah, is it better now? Still the same?
Yeah, it's better. It's better. So we have Vinay back. Great. So it's better now. Please go
Yeah,
ahead.
I can hear you. Yeah, Lokesh, I can hear you now.
Okay, fantastic. Please go ahead. Yeah. So did you hear the question?
Sorry about the. Yeah, I did. I did. Sorry.
Okay, fantastic.
About the Murphy.
Yeah, sure. Please go ahead.
Right. So I'll quickly touch upon. I'll quickly touch upon. I think Gandhali made a very important point that there's always something built. Why don't you fork and start? You don't have to build from scratch. Pick it up and tap into the innovation that you get from open source community and start from there. And I also want to quickly touch upon Dr. Sumit's point, right? I think he made a very important point that you have to take care of the box. You have to take care of open source is not all open, but there is issues that you have to fix the bugs, harden it, make sure it is enterprise class before you fork it up and put it onto your own development efforts, right? And that's where it becomes absolutely important for you guys to have the source strategy in time, price grade support, and that's where on that point, Lokesh, I want to verse as
Your voice is slightly breaking, Mr. Vinay. Hello. I think we can. Okay, let's proceed with the next question I have. This is for Gandhali. So, Gandhali, as I was I've been trying to request you. Can you throw light on what is the main foundation and strength of open source, which will play a very key role in Metaverse?
Sure, Lokesh. So, open source, as we know, have some fundamental advantages as well as disadvantages that Professor Sumit pointed out, right? So, when we look at the advantages, as I already said, there is a speed, there is a cost effectiveness, but also there is flexibility, there is agility, there
Yes.
is a ability to start small and grow bigger as you get more collaboration. You attract better talent and you share maintenance costs. So there are a lot of fundamental advantages, and if you are conscious enough, the disadvantages of open source could also be minimized if you are using the using the tooling to secure your code, making sure it you're doing the code scanning, secret scanning, all that. So if you use the entire package or the plethora of services available to you as open source project, the advantages would always kind of overweigh over the disadvantages. But when you look at GitHub, I'll speak from the perspective of GitHub. It's simply the home of open source. It's the largest open source community in the world. And at GitHub, our focus is to continuously improve the platform and add features so that the collaboration on open source projects can thrive. So if you see today, every new feature we build, like our biggest SKU, which is the advanced security, most of the security features are available for free for public repositories, which are the main source of developing open source software. So that has been the fundamental I would say consciousness about open source. In fact, in GitHub, a lot of the things that the way we work inside GitHub is also the very much similar to way open source project, the collaboration happens. And that's the reason if you simply search on Google, what are the top 10 metaverse project, you will find all of them are on GitHub, whether it is Webverse, Hypercube, XR Engine, and many, many more. So if we talk about what role GitHub will play with respect to metaverse, it will be very similar to the role that GitHub has played in large-scale success and adoption of technologies like TensorFlow for AI, or Docker or Kubernetes for containerization orchestration, or Hyperledger, Ethereum, Corda, all these projects, again, some of the best blockchain projects. So the value that GitHub will bring is to provide the best plus possible platform for software development, collaboration, developer productivity, and the entire DevSecOps field.
Yeah, I think an associated point I would want to check with you is the kind of tie-ups that people will need to have, partnerships will need to have. When they do that, what would be those concerns or limitations for the collaborators and partners? So do you feel there would be limitations, or what do you feel are the aspects when it comes to the co-development and collaboration?
So if you look at the players in Metaverse today, right, Lokesh, on one side we have some really thriving big open source projects, and on the other side we have tech giants like Google, Microsoft, Meta, all are investing big dollars. Like if you see Satya Nadella's Build 2022 keynote, Metaverse is one of the top 10. Companies like Nvidia, they are building next gen hardware, and when I already talked, Red Hat is working on optimizing Linux kernel, while Samsung is working on new memory technologies to make it faster. And again, platform like GitHub where everything can bring together. So if you see, there is not a dominance of one player anymore. All these entities need to come together as they each bring a different aspect and a different value to the table. So I think the next steps we would see is the more standardization across some of the underlying fundamental blocks to ensure compatibility. And some of the obvious concerns that we have about metaverse regarding privacy or the identity theft, overall security, its effect on health, how do you protect your kids, all that, right? The only way to make sure it's safely accessible for everyone and to kind of, to use a correct word, democratize it, is if all these entities work together and they understand that they have to work together. Yeah.
To lay out the mechanisms and standards.
Exactly. So just to take a quick example, Linux started as open source OS completely. Microsoft Windows completely closed source, right? Today they have so many partnerships. So they both traveled a long way. And in today's world, everybody needs other, right? So I think the way forward is it's not a problem that could be solved alone in an optimized way to create a safe metaverse. So I think the working together, collaborating together is the best way forward. And I think all the partners and the players in this space today understand that they have to work together.
Yeah, and I think that will be interesting for us to see when it does happen. So thank you for those views. So I have the next question for Professor Sumit. So Sumit, you were mentioning about the aspects with respect to safeguarding the information flow inside. So I think, can you highlight on a couple of aspects like the IPR issues or the kind of data privacy that would typically happen, and what are those? What are your views on this with respect to the information protection aspects?
Sure. Yeah. So we are already hearing lots of copyright infringement or patent infringement cases around us, and all these are nothing but data privacy issues. So data is getting leaked or misused, or being used, even not misused, being used by someone without the consent of the original creator. And in the real world, we have much better control because we have that physical person in front of us. But if we talk about in metaverse, we do not have anymore the physical entity, and the entity who comes in existence and do the infringement of copyright or data privacy or even commit any crime, a serious crime, the entity can disappear without leaving any marks behind it. So that is a scenario where in the metaverse we may not have the police anymore.
Okay.
The police is there in the physical world. In metaverse, they are just another virtual or digital entity. Now that digital entity can come into existence and disappear without, giving any warning sign. So police can also come into existence, and suppose your digital twin is in metaverse and a police digital twin comes to you. You do not have any way to make sure that police is real or fake. Because in real world, we have our senses which allows us to judge whether it can be fake or real. Whether it's a dress or some symbol or maybe the car in which police is.
The ID cards. So many intuitions, right?
Yeah, sixth sense. In metaverse, you may not have sixth sense. You may have 7, 8, 9 senses, which we have not developed so far, which we may not be aware of. So.
Yeah. So it's kind of a vague environment where we need to be really careful in terms of how we handle things. I think that's a very interesting point in terms of
And
the multi
kind
senses
of
coming into
properties which we are going to create in metaverse, we are not sure whether it will have analogy in the physical world, like copyright, trademark, patent. What these properties will.
Okay, I think we have a break without Sumit. I think we'll see if in case he can come back, or we can move to Kasim. Kasim, are you ready for the next question from me?
Yeah, I am.
Yeah. So I think we have been discussing a lot about the aspects with respect to this virtual world in the metaverse. So can you elaborate on the role of from a hardware perspective, which you really brought out very nicely, the role of semiconductor companies like your company, Texas Instruments, and their open source hardware and software initiatives. What are those challenges to enable, and what are the elements already in place? What are the progress in related areas for metaverse? Yep.
Yeah. So So not just TI, right? Like every semiconductor company today is, as I earlier said in my previous comment, the technology that everybody is using has evolved considerably and exponentially, whether it is in the die size, in terms of low power, in terms of security features, inbuilt security features, and analytics. So all these features have evolved in its own space. Today, each and every device, whether it is a normal lighting or a smartwatch or your automotive devices, everything, they are all connected to network and they are all getting issues with the security aspects. So now a lot of focus has been put through in semiconductor companies to resolve the security aspects. It's like the days when we were finding issues with toggling the GPIO or connecting PCIe cards and finding drivers for our USB devices. I think those days are gone. Like the industry has evolved in those things today. We no longer find those things as an issue. But the next issue today we are seeing is in terms of processing the data at the edge, right? Like at what rate we can process the data, consume the data, store the data, and while we are processing or take the security aspects starts when we pick the data, process and store. So at all three areas, like while the data is getting passed through, high-end security is required, and then the chain of trust has to be built in the software from when the data is transferred from one component to another component. Now that we are bringing these open hardwares out and giving software ecosystem a ease of use in terms of low-cost hardware and high-end design, like for example in Texas Instruments we have this initiative called Edge AI, like where our software is completely giving you the accelerated AI with TI DSPs, and it is public and open to start using it, consuming it, and programming on top of it. Now, these kind of software, when it's available, like if you go to BeagleBoard AI, there is a BeagleBoard platform which comes with AI software, and it also has high security. It also has high security features. So security, analytics, and open hardware like BeagleBoard, and the software is completely open source. So now these kind of platforms can be targeted for the next generation class of ecosystem that we are building, or next generation class of topics that we are going after, like Metaverse things, right? So for these things, these technologies are very much essential, and it is readily available today. As I said, like BeagleBoard AI and the analytics and security, plus Linux operating system, I think that is, and accelerators. So all these things put together are readily available today that can be used.
Yeah, that's very, very interesting. I think good point actually. So while we are discussing on one hand, how do we provide this security and information safety while we are doing the storage, processing, transfer, all these things, I think what you mentioned is really interesting from hardware companies like TI. I think this is the right way forward, probably, right? So thanks for your views. I think we have, I mean, while we are discussing all these things, we did dwell when Biju was mentioning about the legal aspects. There are two interesting questions for Biju from my side. So one of them is, I mean, as we were discussing, nothing comes for free, right? So nothing, I mean, free versus open source. So there are bounds, there are legalities, there are regulations for usage and all that. So how do you see the landscape changing from this physical to virtual world, Biju?
Yeah. Thank you. Thank you, Lokesh. So, courts across the globe are grappling with issues which comes with Metaverse and from the traditional, use of IP. So, in some cases, we have this case of M.F. Hussain, the administrator of M.F. Hussain's painting, had sent a cease and desist notice against an entity which is Tamarind in New York, who were trying to print some NFT on the basis of the paintings they had purchased from M.F. Hussain. So based on the cease and desist notice which MF Hussein's administrator has sent, the Tamarind Art Gallery went and sued, filed a case in the New York court, saying that they have the right to mint this NFT because the rights have been provided under those agreements.
Okay.
Matter is still under litigation in the New York court, but it's interesting to see whether, for any business across the globe, how they have audited their, agreements, how they have reviewed their agreements, whether the rights extend to Metaverse or it is limited to the physical world. So that would be one interesting point which all companies across the globe has to look into, audit their agreements or look into their IP rights. That's one. Secondly, unless you don't have a presence in the Metaverse, the chances of confusion, like if you, let's say you have a trademark in the physical world, but you don't have any presence in the Metaverse or the virtual world, then the chances of you getting an injunction on a trademark misuse in the Metaverse is very less. This happened in the case, one of the cases which was brought before the US court. And so this is by the name of ESS Entertainment versus Rockstar Videos. Held that the depiction of the trademark in video games does not infringe the trademark of the owner, as the video game is an artistic expression protected by the First Amendment. Secondly, the consumers would not be confused between the trademark produced by the sophisticated video games. So, unlike the physical world, you may not be protected in the Metaverse unless you have some presence. So that's why companies across the globe have started also having their presence in the Metaverse.
Separate.
Not just filing for IP in the Metaverse, which is virtual goods, but also having some activity. Like Nike today is litigating against another player in US as we speak, where Nike also has a virtual presence. They have filed for IP in the virtual world, but still their litigation is going. This also reminds me of a litigation which has already got over in China, where the Chinese court recognized that unless the agreement doesn't give you a right in the virtual world, per se, there is no right in the virtual world. If you have just a physical presence and you don't have any rights in the agreements, then there is no right. And secondly, it also looks at the factor that when there is an infringed goods provided, so it provides an onus, it puts a lot of onus on the platforms, online platforms, to do basic due diligence, to look at the ownership, whether the person who is uploading on the platform of these companies, to do a due diligence, look into the ownership rights, and then upload the NFTs on those platforms. Otherwise, the platforms could be head liable, and platforms also has to take down this infringing NFTs and put into a system where that this is not reused by anybody else. So a lot of onus has been put by this Chinese court in case of T. And they also have talked about an ether address where this infringing NFTs has to be put in and removed from circulation. So this all brings to a lot of issues which traditionally businesses would not have thought about. But businesses, if they have to have a presence in Metaverse, they need to do various things. As I said, relook into their agreements which they have provided, relook into their content licensing agreements, relook into their IP strategy in the Metaverse if they have to have some presence. And as you all said, collaborate with other companies, maybe in the open hardware space, also on the open software space.
Yeah, so my next question is connected to that aspect. Basically, it's nice that you brought the point. So, while what do you feel are the best practices for the businesses while actually collaborating in this open source context? When we try to extensively use hardware, software, open source for building Metaverse, what are those best practices businesses can have? from a legal perspective, right?
Yeah. So from a legal perspective, unlike the traditional real world IP filing and stuff, companies need to revisit their agreements, existing agreements, and to see that what rights have been provided to in those agreements. If
those, yeah.
Yeah. So, and then accordingly plan. Secondly, relook into their IP filings and see whether they are also filed for virtual goods or service.
Okay.
So
Okay.
globally, if you don't do it, then you are at a risk of losing the rights in the metaverse space.
Yeah, it would look like the patents or whatever claims that we make, you would have claims which are specifically for the physical world and then claims for the virtual world as well. So it's kind of, we need to extend the whole thing into a larger gamut of things. Otherwise, we're going to lose out on this. So businesses are going to lose out on this while we are trying to use this open source and try to build all these building blocks and so on, right?
Especially trademark, you would lose surely. So that's why I give the example of that case in US where they lost on the trademark because they didn't have any presence, so there was no confusion, and the court did not grant the injunction. So it's very that you should file for trademark in the virtual world. So for virtual goods, so that and on top of it, companies like Samsung also has brought land on Metaverse to show their presence. Companies like Nike has started selling products and where you can virtually review those products, buy those products, and also started minting NFTs on those products. So this way, companies have to show presence, otherwise they might lose their trademark in the metaverse.
Yep. Thank you. I think that's great. I think if we look at now, from these discussions, what is clear is, on one hand, we have to look at the complexities with respect to handling the data and how the whole ecosystem scales up. On the other hand, while we are doing this, there are a lot of legalities and bounds that we need to look at. And we need to separately address aspects for the physical versus virtual world and not just make assumptions that things are going to hold in both the places.
Yes.
So that way, I think, this is going to be pretty interesting, though complex. Definitely, we're going to have a whole lot of things to attend to when we traverse into this metaverse domain, right? I think good points from all of you. I think we have the last 5-10 minutes probably we can use for any open questions from the audience. So Dwarka, can we have the audience unmuted so that they can ask questions to the panelists?
Sure, Loki. So
yeah, thank you.
Audience on the call.
Any questions
Is anyone
from the
having
audience?
any question? Just raise the hand. We'll unmute yourself. You can unmute yourself by here.
Yep.
Looks like it was a difficult topic to digest.
We can take 1 or 2 questions, so we have another 5 minutes. People did understand the various dimensions of
it's quite
the
different topic, right?
Altogether. Yeah.
There is a question. There is a question.
Okay.
Yes, Dr. Ganeshan, please go ahead.
Yeah, it's a nice discussion. Thanks for all the panelists for a very interesting topic. And Loki, I think, was nicely summarizing all of them. Very good. So my question is slightly different. We have been talking about, I mean, at least the way I understand is the metaverse is mostly from B2B or commercial point of view. But now when it comes to, say, from communication point of view, like, is there any different way that you can communicate? For example, virtual conference in the metaverse, right? It's more like a Star Wars kind of conference between the Yoda and others, right? So it is something like that. Is it something feasible? For example, you are sitting in a conference room alone in a chair, and then now you go to the metaverse, like the other chairs get filled, right, with the other participants. So it's like a lively conference, like a communication. And like, is there anything that any products or something it is coming up in that? And what are the nuances there? Like, are the common problems or common issues in that, or is it something different?
Okay, I can take that question. If anybody else wants to take the question, panelists. Okay, my quick reply, Ganeshan sir, is the following. So if you look at, there are many players who are already looking at templatizing many of these things. So if you look at virtual conferences and virtual meets, as I mentioned to you, there are 4 pillars which we're looking at. The virtual interactions on one side, virtual places on one side. So people have already started attacking these virtual places in terms of creating standard templates that can be used easily. So those will, I mean, though not open sourced, but they could typically be used for the sake of the kind of purpose that you are mentioning. So in the virtual world, does that answer your question?
Yes, I mean that answers the advantage part of or the platform available for creating such an environment. But what are the other aspects, like legal aspects or other identity
So
aspects?
using those templates across virtual worlds, across different metaverses. Are you mentioning something like that?
Correct. Yeah.
Okay.
For example, if a Microsoft employee is going to talk with someone in Google, maybe using different, completely different platforms, right? Is there a common platform like a Zoom or something where, or Red Hat comes up with one, something like that, right? If there is something which is a common platform where, irrespective of from which company you are representing, you should be able to conference.
So you can come together.
Yes.
It's a very interesting thought, Dr. Ganesh. And I think, I don't know if the whole interoperability depends upon this fabric where, different organizations, different people from different organizations can come together in one platform. I think that should be the future of Metaverse. Hopefully we get there one day soon.
Yeah.
I think as of now, we don't have that level of clarity as such. We are sure that these are the things that have to be solved, right?
Okay.
Yeah, from the legal perspective, Biju, you have any perspective?
I think identity masking would be something which will be very interesting in the metaverse.
Okay.
You will not be disclosing your real identity, and maybe some of those questions which without the corporate tag before you can be taken off, and you can ask those questions.
So you're just 2 entities in the virtual world. Rather,
Yes.
you're not identifying yourselves as either Google or Microsoft or Samsung or whatever it is. So it's kind of interaction between 2 individuals who are interested to interact.
Yes, and obviously enforcement also will be an issue there. Track the identity, and maybe so that's where I see a lot of opportunities for
Sorry to interrupt you. Actually, my thought is completely opposite. I want the identity to be kept. So, for example, if you want to go to an IEEE standard, right, where multiple companies represent the standard body, there the identity is most important. In fact, the identity has to be, it's a must, and it should be perfect. There should not be any fake in it, because the voting rights depending on that, right? So, in fact, identity should be maintained, but at the same time, you are not violating any of the privacy policies, data policy issues, right? That's the most challenging part. I mean, otherwise, I can create an avatar in some virtual world, and then I can keep talking with anybody, Elon Musk or anybody, right? So that was my thought process. Sorry to interrupt you. Yeah, please go ahead.
Sumit, you have a viewpoint, Sumit sir?
Yeah, so when we talk about the identity, I would say even if you say Sumit is there in Metaverse, it's not actually Sumit, it's a digital twin of Sumit. So we need to be very careful. Although it's a digital twin of Sumit, is really the Sumit who is controlling that digital twin or not? That is more important for us. So identity will lose its meaning what we understand today in Metaverse.
Yep. I think that's a interesting angle, because the digital twin which you create, or avatar you create, your avatar over there may not exactly behave like you, because it's not fully trained like you. Unless we really fully train like ourselves. So which is going to be a humongous task.
And we have seen so many sci-fi movies which shows that what can happen.
Yep. Okay, I think interesting. Let's. I think we can park the questions. It's going to be interesting to discuss this in future discussions as well. Thanks, Ganeshan, for that stimulating question. That was interesting, I suppose, for many of us. Any other questions? Quick question, or I think we are just over the time, Dwarka.
Yeah, thanks everybody.
Thanks, connection. Yeah.
Thank you.
We can connect offline, right? Thank you.
Yeah, sure.
Thank you. So finally, we are at the end of today's event. And as they say, the less is more. Usually when some session is shorter and it becomes interesting, we feel that we need more, we become greedy. So probably this is like a good indicator that we're going to have probably a sequel of this panel sometime soon with a lengthy discussion. And I feel that this was a good trigger for the audience also to think more deeper. So to summarize on today's event, first of all, thank you for those all our audience or participants who were there throughout the event. I have been watching the list, and there were 50 odd participants. They were there right from the start till end. And we had like a churn around where 120, 125 plus participants were changing regularly. So we started with Dr. Alok, who summarized on how this event was formed, and we reached at this pinnacle. Probably next year we might be having a physical event, hopefully, because this is a third edition in the virtual mode. Then Corporate VP Mohan summarized us on what Samsung is visualizing on open source, how Samsung has been framing this whole journey back in 2000 and now where we are. He also spoke about collaborative innovation, and our Galaxy series has been one of the powerful product which has been powered by open source. Then talking about the GitHub, Karan brought very interesting numbers. I mean, I'm sure most of us must have never heard about such numbers that he displayed in his slides. Probably that's the GitHub that had it, and we had an opportunity to see at those things. And one of the important thing that he emphasized, and Loki, you also mentioned, was documentation. It was interesting to see that how much impact it has on success and the outcome of the project over there. Then we had the interesting demo and a sort of a walkthrough on a tutorial of the 5G testbed from Dr. Chandra. That was also an interesting setup. He showed his lab, and one of the interesting thing was he has opened the URL to everyone just in case if anybody wants to look at it. That's very interesting. We did have these two startups where we observed on what they are emphasizing and what they're about to come in the market. While Zero Lab is into security and privacies, where they're totally different and homophobic kind of things. While Abhijit was on the Neural OS side, and they have already demonstrated successfully a couple of things, and he also brought in the angle of how they're going to take it into AI, AR, VR space going forward. In the live action, we saw the network slicing from Samsung. That was another interesting take on the call today. It was, though it was difficult to demonstrate such kind of application, but engineers made it possible by having a pre-recorded pieces or Lego blocks coming together and in the form of stitching between the slides and the recorded video. Subodh brought in a very interesting perspective of that full stack observability. One of the interesting way that he brought was the metaphor, the way he used a coffee house of the cloud. That was a very interesting way to demonstrate that scenario, and he was in probably a natural corollary of the flow that happened right from the starting of the event till that point. And then we had this quite healthy debate and a live discussion where we were able to see the contradictory views and supporting views coming from multiple perspectives. Couple of keywords that were like circular ecosystem, open source at the ground zero, and we had something sort of like hardware first, where Qasim brought in some interesting perspective, open hardware. While Biju was playing the legal expert on the legal implications, he brought in very interesting points. Probably, and most of us might not even be, knowing about those things because we don't follow these legal suits usually in a day-to-day life. And apart from that, I think the interesting thing that we heard about was about the security issues, templatization that you brought, and the identity masking. While Dr. Ganeshan had a different viewpoint, he wanted to reveal the identity in a real form. So that's another challenge that probably Metaverse is going to face in future. So that's great. That's like a quick summary of this. I would like to thank again IEEE ComSoc Bangalore and Samsung for coming together. I would also like to thank our collaborators, TSDSI, Standards Partner, and our media partner, Open Source India and Electronics for You magazine. Thank you, everyone, once again. And those who are still on the call, I would like to mention one thing that IEEE is going to issue a certificate of participation to everyone. So soon you get in your email. I look forward to see you all next year, most likely in a physical space, not in a metaverse space.
Thanks to all the panelists, Dwarka. I think they were very active. Thanks to all the panelists.
Thank you very much. Biju has raised a hand. Yes, Biju. You are in mute.
Yeah. Thank you, Dwarka, for being a host.
Pleasure. It was pleasure.
For being a wonderful host.
Yeah,
Yeah.
thank you.
Bye.
Thank you, Loki and Dwarka.
Yeah, I would like to, from IEEE ComSoc, I would like to thank Dwaraka, and there are a lot of behind the scene people who made it possible. So thanks a lot. And Dwaraka is the one who coordinated the whole thing. Yeah, thanks a lot. Yeah, and it is, I enjoyed the whole event. Yeah, thank you.
Thank you, everyone. Have a pleasant evening. Bye-bye.
Thanks, Dwarka. Thanks. Bye.
Bye.